So I don't know, hello YouTube or something, whatever. Something like, in this video, a really high energy introduction. No. I am joined today by Richard Carrier. I'm not going to do any introductions because I imagine that everybody watching, if you know who I am, you almost certainly know who you are. So there's no
Yeah.
point wasting time on that one. I'm getting a bit of kind of like, sounds like sort of road noise or something. Have you got an open window?
I do. Yeah. Is that a problem or?
It's a bit distracting. I don't suppose it's too much of an issue, but I mean, if you
Okay.
need the window
Yeah.
open because it's hot, fair enough. I understand.
Well, let's see what happens. Let me do that. Improved.
Yes, that is like perfect.
Yeah. All right. Excellent.
Okay, good. Um, cool. So I can see there's people in the chat. So I can sort of see. I'm not gonna like watch the chat very much, but if there's any issues, like you can't hear one of us or something, just say in the chat. I'll eventually hear it. Even though in the past I have gone on for ages without noticing people saying stuff in the chat. So we'll see. All right, cool. So this is a discussion between us because basically I was doing some stuff, I don't know, 2 months ago or something. I took some ideas from some viewers, and one of them said, "Oh, you should read this blog post," and linked your Ontology of Logic post. So I started reading it and thought, "Oh, go on then, so make a couple of videos, bit of content going through this." So I did
Yeah.
that, and then I don't know whether did you watch either of them or
Yeah. I watched the first one. I sort of skimmed through the second one.
yeah, fair enough,
It might come up. There's a reason why. It might come up as we discuss, but
because it was shit.
no, it's the opposite. I didn't have really much to dispute in that. I think like it was. I feel like you went off on a tangent that kind of missed the point of my article, and so like everything you were saying was correct. It just wasn't applicable to what I'm talking about.
Okay.
Like I said, that'll come up. The second video was really good, by the way. A really excellent survey of stuff there. So that was more organized than the first one, which was a
Oh
bit
yeah, first
rambly.
one
Yeah.
just off the top of my head. Yeah, absolutely. So
Yeah.
I apologize for you having to sit through that first one, but fair enough. Okay, so um, I don't know if there was. I got like a tiniest bit of structure to go through, which was basically the
Yeah.
3 points that I was bringing up. But I'm happy to let you go first or whatever if there was something
Yeah,
you wanted to
I've
say.
got this. I created these one page summaries of stuff, and so I've got a one page. It's like less than like 240 words explaining the whole article, and everything else in the original article is just examples, background, explication, etc. You can reduce it to just these like 240 words, and I thought maybe I could walk you through that, and then
Sure.
we might refer back to that document because then we've got specific propositions we can look at and dispute and whatever, and then also orient the audience because I don't expect the audience has read the whole article and watched all the videos and all of that too. So like it would make this like a self-contained discussion. They could just watch this video so you and I
Sure.
talk about this stuff. So that's the goal anyway. Let's see. I'm gonna share screen and see what happens. Window share. Boom. Okay. So yeah, so this is like what the paper is doing. Now I should also point out that the article is colloquial. It's for a popular audience. It's not like written to like be published in a philosophy journal or anything like that. Um, but generally, this is what I was trying to get at in that article. And so the question, why does logic describe reality? Reformulation of that is why are conclusions of logic true of physical reality at all? In other words, we can talk about propositions in logic being true or false, but why are they also true or false of the real world? And consequence of that is like, why can't logically contradictory states of affairs actually exist? Like, what's preventing that from happening, for example? Oop, went away. Okay. And then, so the context. So, and this is an important point I think you and I will dispute or discuss a bit. Is that so? My position is that logics and maths are essentially games with rules that humans invented. Now, we invented them for a purpose to accomplish things, so that constrains what we can invent. And for logics and maths, it's to discover or understand something. What quote unquote something is, it's what we'll get to later. But the rules of most games, like let's say chess, Monopoly, Dungeons and Dragons, and so forth, they don't govern reality, but the rules of all accepted logics and maths do. So the question is why? All right, so then that's the basic framework. And then the thesis is logics and maths describe distinctions and the consequences of there being distinctions. I might come back to this as the blue line later, but and that distinctions means possible or actual, so we're not limited to just what actually exists, but also what possible distinctions there are as well. And so I noticed in your first video you kept wanting to try and categorize my position. I was specifically, we might get into that later if you ask, am I a nominalist? I have a whole one page on that too, but very briefly there, if we want to put a label to it, I have problems with putting labels to it, but if we want to do it, it's modal structuralism. So I'm mostly in agreement, not necessarily with Jeffrey Hellman. He's like the foremost and first proponent of this version of nominalism. There's been a lot more since, and I haven't thoroughly read them all, so I don't know who solves which problem in which way and so forth. But the general position that I'm in is in the ballpark of modal structuralism. So the idea is that all propositions in logic and math are about possible structures, and it could be actual structures, are all obviously also possible structures. And structures are constituted by distinctions. That's how you tell one structure from another, and therefore conclusions follow as you start making distinctions between different structures. And so this is Hellman's version, or this is Hellman's position. There are other modal structuralists since then. And I wanted to avoid the baggage fallacy, which is, and I'll just state this here, is it doesn't mean I agree with or am committed to every single thing Hellman said. Or any other modal structuralist. I have the problem that once I say I'm a nominalist, someone comes in and says, "Oh, well, then you believe X, Y, and Z," and it's like, no. So, and I saw you do that when you were assuming that I'm committed to the existence of actual infinities, and I think we'll get to that later. I'm not. I don't think any current nominalist is committed to that. Like fictionalists aren't, and deflationary nominalists aren't, and structuralists aren't either. So. So that's an example of like what I call a baggage fallacy, assuming that a position, once you label it, it comes with all the baggage that is supposed to come with that position. And I wanted to try and avoid people doing that by not saying what position. Now I didn't want to give it a label because I didn't want them to bring all the baggage with that label. I just wanted them to listen to like what's my position. Here's the internal contained argument for it. That was the original goal of the article. So I just want to bring reference to that because that might come up again later. But I mention it now because it seemed like you really wanted to know, like, where am I in the field of philosophical debate on this right now? And I would say, yeah, it's Hellman modal structuralism is where I am roughly. That's the ballpark. And one other point that I saw you kind of struggle with, or at least not understand what I was doing with it, is this crucial point at the bottom, and I'll call this the red line. The rules and notations and proofs of logic, like the axioms, the syntax, the semantics, those are not the same thing as the thing they are describing, the ontology, the underlying ontology. This is kind of part of the point, like the first half of my article is about this. So what we have had to do to describe the axioms, laws, proofs, propositions in a language, we can't mistake that for what it is that those things are describing. And to give you sort of a silly thought experiment on this, is like I call it the Nantucket rule. Like if a million years ago, let's say a million years BC, in Nantucket Bay, there was no propositional logic, there was no first order logic, there were no symbols, there were no proofs, there were none of that stuff. And yet it was still the case that things were either the same or different, right? So distinctions still exist. So it's either the same or different, and therefore things can't be both the same and different, and therefore things that are the same are the same, and so on. So like all of that stuff follows from the existence or non-existence of distinctions. It's the same ontological fact. Like, now, how we learn that fact, how we prove that that's true, like those are like semantic and epistemological problems that we invent logics and maths to do. So anyway, that's the basically the short of it, right? Of what the paper likes, what I thought I was doing. I don't know if I succeeded very well or not, but that's the basic gist of it. And I think from there we can start through your list, or you can immediately start bringing up issues that are showing up here. On this sort of 9-line or whatever.
So, no, I think that's really helpful. So thanks for spelling that out. I can sort of understand what you mean by the baggage fallacy, right? I'm not expecting you to say I believe everything that philosopher X says. I'm a card
Yeah,
carrier,
yeah,
whatever, blah blah. I mean, when only the most sort of introductory, uh, like a student who's reading philosophy for the first time, reads Hume for the first time, is like, oh fuck me, Hume's amazing. I think everything that he said was right or something. After a while, a few years
yeah,
of doing
yeah,
philosophy, you've got the rug pulled under any sense
yeah,
of
yeah.
certainty. You read Hume, then you read Kant, and you think, oh Christ, the Hume was wrong about everything. And that sort of experience means that you're not going to be 100% signed up to anybody. They have interesting
Yeah.
ideas and things you like about them, whatever. So I'm definitely not going to pin anything
Yeah, and
like
I
that.
think but speaking from like the perspective of when I wrote the article, like the audience I was thinking of, I get bad faithed a lot, right? So like, that's why I'm not thinking of you specifically. I'm thinking of, there's other bad faith operators who do this. A lot of people do this, and you kind of did it like it wasn't like that you were attributing to me something someone else said, but you had this assumption that nominalists are committed to actual infinities, and that isn't
Well,
actually the case. But that's an example of a baggage fallacy where you assumed that nominalism comes with this commitment. And I was trying to avoid that,
right, right.
right? But
So,
maybe I wasn't successful. That just wasn't a successful strategy in writing the article.
right. So that idea that, well, so nominalists, in particular, someone who wants to do, say, who wants to carry out a program of nominalism with respect to mathematics, right? Who wants to say something like talk about mathematics, doesn't refer to, like, talk about numbers, for instance, doesn't, like, it's just normally refer, like, it sounds like when somebody is a mathematician is saying there is a number such that it's,
Hmm.
greater than 5 and less than 7 or something, right?
Yeah,
That's a straightforward understanding of what they're saying, just a sort of naive semantics or something. They're quantifying existentially. They are committing to the existence of some things, right? A nominalist is going to come in and deny that and say, no, that's not right. I'm understanding their talk in a way that doesn't commit me to the existence of those things, right? It's a basic fundamental move of the nominalist, right?
yeah, right, yeah,
But if you want to say, as I thought, I mean, explain to me what I'm getting wrong here, but like, I thought you said, look, listen, mathematics is this kind of thing we make up, like you're saying up here on the screen. I think, let me just
yeah,
say, maths is essentially games and rules humans invent to accomplish things, right? So this is
yeah.
kind of like instrumentalist idea, right? But then when it comes to the, the stuff mathematics is about, you were saying they're about quantities, right? And quantities, I think you explicitly said, are physically real, right? So if
Yeah,
it seems to me that
potentially or actually, but yeah,
sure,
yeah,
potentially or actually, but the point is that the standard realist interpretation is that when the mathematician quantifies over numbers, then they mean that there is this thing called numbers. The nominalist blocks that. They can either say something like, well, it's to be taken fictionally or in some way, not truth apt statements or something. Like if you want to go I don't know. There's a range of sort of
yeah,
non-realist options you could take. But it sounded like what you wanted to say was, well, I can eschew talk of numbers because I can substitute talk of quantities that are physically real in their place of talk of numbers. And so that made me think, well, that's quite similar to Hartree Field, right? Because he also wants to have this nominalist program in mathematics. And he has this book, I think it's called like Newtonian Physics Without the Numbers or something, right? Where he's trying
yeah,
to
right.
reconstruct a physical theory, but without straightforward reference to numbers or something. And in that, he ends up saying, well, if I want to be able to do mathematics, like interesting mathematics, then there needs to be enough stuff. The thing that I'm substituting in place of the numbers has to be able to do all of the work that the number talk was doing. Um, and it just seems like, well, he thinks then that he has to have like continuous space time and stuff, so he can have um,
This
real
is where you're
numbers
getting that from.
effectively.
Okay, right.
Yeah. So it seems to me that like if you're committing to saying, here's my account of what mathematics is, I'm not saying you have to say anything else that Field says. I mean, we can even forget that he says that, but isn't it
Right.
just true that like if I mean here's another distinction. Sorry, I'll shut up in a second, but some accounts of the ontology of mathematics are revisionary and some are descriptive, right? So a revisionist account of mathematics is like intuitionism, where they'll say, unless a formula has been proven to be true, it's neither true nor false. So some claims like continuum
Right.
hypothesis or something, we just have to say it's neither true nor false right now. Whereas classical mathematics is going to say, no, look, every theorem is either true or false. You might not know it, but it is
That's
true or
right.
false.
Yeah.
Right? So the intuitionist revises down and says, even though the mathematician talks like that, they're wrong actually, and real mathematical talk is like more restricted than that.
Yeah,
So
that's
your
similar to
nominalist,
deflationary.
yeah, yeah.
Deflationary nominalism does something similar.
Exactly. So the last thing a bit then, just to wrap this up, is my point
Yeah.
was that like you could be you could be revisionary about mathematics because you might say something like, listen, like numbers are fictions, but the real things that exist are physical things. And then it's just like, do you think there's infinitely many physical things? Is there enough structure in the world to play that role? And if you think yes, then it just seems straightforwardly that you must think like field, that there's like infinities that are real. Because otherwise, if you don't, then I think you have to say, well, there's only enough, like the intuitionist, you're going to say some statements like that there's, I don't know, Graham's number of things, because that's more than there are even particles or whatever. That statements about those sorts of numbers, they're just strictly speaking not true or false, because there's not enough stuff in the world to make them true or false. So you're going to be revisionary in the same way that an intuitionist was. So I was just sort of curious. I mean, this is not like a gotcha, but what do you think about that?
Yeah. Yeah.
Are you
I know
wanting to
I'm
be a revisionist or
definitely not my position. No. No. I'm like I said. I'm definitely in your categorization a realist. And so if you we've talked about the modal structuralist perspective. So they're talking. So numbers. So the numbers are a very simple example, but they'll work since they come up in my article. Is referring to structure. Essentially, there's a structure. There's a structural difference between 9 things and 8 things, right? And so every number corresponds to some sort of structure. So what the structuralist says is that they don't have, those things don't have to actually exist. Like we don't need to have actually 1 billion apples. All we need is that it be physically possible, right? That we can describe a situation that would, if it were realized, it would actually exist, and it would work. And there's nothing to prevent us from doing that conceptually. Um, if you can get into like, well, quantum mechanics prevents things. Is it? Yeah, but what if you physically changed the underlying structure of quantum mechanics to let you do the things, right? So the idea is that most of mathematical talk, I mean, some mathematical talk is talking about real structures, because that's practical math and so on. But most math is talking about possible structures. So we're talking, we can imagine a possible structure, and then we can move around in that possible structure. It's kind of like a virtual model, and we can ask, well, what's true and false about this possible structure, and then we can transfer that to reality. Say if we ever build that structure as described, it will have all those properties that we found, because that follows inherently in what it is that we've described. So all this really requires is any possible physical instantiation. I mean, you could get sort of meta and say like, well, what if you start with absolutely nothing? Would logical truths then be a thing? If we set aside that's a whole rabbit hole of its own thing. As soon as you have any space of any size, it could be finite space, you have all infinite possibilities. So like you have that finite space, well, then you have the possibility of replicating or increasing that space to an infinite size. You don't have to actually increase it to an infinite size, but that possibility exists inherently in the finite space. And so you can talk about, like you're sitting in that finite space, you can talk about what would be the properties of this space if we expanded it out to infinite size, right? And what would be true and not true about it. And you can get to things like, Hilbert's Hotel. No one has to build Hilbert's Hotel to actually work out like what would possibly be the case or not possibly be the case for Hilbert's Hotel. And so that's what Hellman and other structuralists are saying, is that this is all, you could think of it like, some people talk about it as counterfactual or hypothetical or whatever, but all that it really needs at the base is that fundamental basis. Let me see, do I have, yeah, I have the extended Hellman. I could do that line. We could do this page if you want, but that's my basic answer to your question. That I have another page where I've broke it down into 12 propositions, less than 300 words. If you want to walk through that, I don't know, or if you want to move to a different topic first. I know we'll get to the infinities question later. I've got a page for that as well.
Okay, so I mean, yeah, it's helpful. So you're saying, I mean, right. So if it comes to like a modal structuralist account, um, then it sounds like, and this isn't really a criticism again, I don't gotcha for this part of it whatsoever, but it sounds like a lot of the ontological work is being done by your theory of possibilities then in that case. Like, what do you mean possible structure, right? Is that
Right.
concrete reality somewhere in the multiverse? Is it ersatz, linguistic creation, etc., etc.? So it does feel like I think in some respects all of the options are still on the table. Just to say that you're a modal structuralist, I still want to say what type of modal structuralist then? A realist
Yep.
one, or an anti-realist one, or a, well, blah blah
Right.
blah. So
Right.
they're all right. In a way, it doesn't really answer the question. I'm not to say. I mean, I understand it to some extent as a move. I think. Yeah, you know, there's different types of structuralism, like anti-REM structuralism, in rebus structuralism, whatever. The
Yeah. Yeah. Right. Yeah. And
Christ.
again, I haven't even myself surveyed them all. Um, yeah. So, like, how do I approach that? So, the basic idea is that yes, this is fundamentally an ontological theory, and so we're just proposing a theory to explain everything else that's going on. Like, why, how did logics? So, how do we choose between acceptable and unacceptable logics? And that really does come down to: do we believe the axioms are correct, right? Like, the basic principles, do we believe that they correspond to reality? So any like system of logic that would start getting empirically disproved results, like reality doesn't agree with the results of your logic, we would throw that logic out. So we are constraining what we call logic. Same with math. I think I don't really think the distinction is great between the two subjects, but so logic and math, like, this, the same concept is that we're trying to get some sort of system of symbols and computation that allow us to work out truths about something, quote unquote, in the real world. And so the question is, what is that something? And if we go back to, like, the blue line, if we go bringing that back up, that's what I am proposing as a hypothesis. That is, I think that's the something that we're getting at with logic, and therefore why logic always applies to all possible worlds, including in our world being a possible world. It includes that. And so this is, yeah. So if you think of it in those terms, this is a metaphysical commitment. I empirically possible that I'm wrong about this. If someone could come along and say, no, no, it's this other thing, totally possible. But what I'm saying is, if you do this, all the information we have lines up. Like, we don't need anything more. Like, this works. Like, so why do we need anything other than that? And so that's kind of like the position I take, I think, if that makes sense.
Um, yeah, I guess I do find it kind of confusing, the idea that mathematics is like empirically verified or something. I mean, um, if or even stranger than that, that logic is empirically verified. It seems to me. Well, what do you can you spell that out a little bit? Like, I mean, I could understand how you might say so. Yeah, there's this distinction between like which mathematical structures are the best ones for physics or some other empirical science, engineering, whatever, right? Then there's an empirical question about which ones are like best or something. But if you just talk to a number theorist about what they're up to, they don't care if it corresponds to reality. I mean, what difference does it
Yeah,
make to them? They're not counting swans or something when they're doing number theory. They're just doing their own thing. So
that's a good question. Yeah.
they don't
So,
care about the
yeah.
correspondence to physical reality. So why, given that they're not worried about that, why should I think that you're right in the claim that it really is in fact an
Yeah.
empirically
Yeah. Yeah.
governed
Uh,
thing?
Number theory would, like, there are structures in number theory that do correlate to actual physical things in the world. So you could test number theory and disprove it. Like, you could falsify it. And I think if that ever happened, number theorists would be sorely unhappy, and they would think, well, there must be something wrong with number theory, right? Or we're doing it wrong or something.
Well,
There's
what do
this
you mean?
implicit
What sort of thing
assumption.
do you have in mind? Like, what sort of test could we do?
Uh, oh, uh, Gosh, now I'm going to explore the field of number theory.
Well, any
Well,
branch of mathematics, it
would
doesn't
we
have to be.
include, like Cantor's, his whole cardinality of infinities, that whole game? Like, would you include that as number theory, or do you want to pick something more?
I
Like,
don't
what's a
mind.
really basic?
Like
What's a really
arithmetic,
basic proposition?
a really
Well,
basic mathematical proposition.
yeah,
Like
yeah.
one.
Well, I mean, if you're just saying arithmetic falls into number theory, obviously arithmetic can be tested, right? Like, you can come up with all kinds of arithmetical equations, and then you go actually perform the procedures physically, and you get a different result, then clearly your arithmetic is wrong, right? I think this kind of came up with, what was the guy who that was on Joe Rogan's show trying to claim really bizarre things about arithmetic, and that's a good example of like number theory that was empirically false, and you can show it's false by just like organizing the structure, like actually building the structure that it's describing and showing that it does not match what's on the other side of the equal sign, right? So,
Well,
um, but a lot of that's so a lot of number theory, of course, is about possibilities. So the question might be, how would you test something that's possible that you can't build? And that comes down to the axioms, right? And so the axioms and rules that you build, like, do those have an ontological backing such that can we test those against reality, and do they hold up? And the reality is they do. And so that's why number theorists use the axioms and systems they do. Same with, any other logic or any other mathematical system.
so like, if you are going to calculate the trajectory of a cannonball, coming out of a cannon, you'd probably use a differential equation, which would have two solutions to it. Typically, one would be discarded because it would be like a negative number,
Hmm.
right? But I mean, is that an empirical worry? Should we be
No.
concerned about that?
Well, no, certainly, because now you're talking about the procedures, right? You're talking about they've written down a set of computational procedures to get a result. And so part of the procedure of that is you reject null results, right? So like a negative result wouldn't, like, obviously is not the correct result for what you're describing, right? It describes something like alternate dimensional physics or something like that.
Hmm.
You'd have to dig into like, well, what would be the significance of there being a negative number solution to this? And that's generally because you multiply negatives against each other, you get a positive, and so you're getting into the whole domain of like imaginary numbers, where imaginary numbers are actually the number line rotated 90 degrees, right? So if you
Yeah.
rotate out of the number line, you've got the imaginary line. So these are all possibilities, right? So you could describe any system with the correct geometry that way. So I mean, I myself have not sat down and figured out what could be the physical realization of the negative result, the rejected result in those equations. But there's only two possibilities. One is there is some sort of physical system that it would cover, and it just wouldn't apply to the one that we're describing. The alternative is that the procedures are generating only one good result and one bad result, and so that's a problem with the procedures, not with reality, right? And so that wouldn't, as long as it's getting a correct result that we can test, the fact that it also gets this invalid result doesn't matter to whether the method has been tested out, right? And so, like, yeah, I think there'd be something interesting to do in terms of what is the ontology of the other side of factorial, or of the double results and multiple results of differential equations. I myself haven't thought that through, but the structuralist would say there's got to be either something there or it's just a problem with the system we're using.
Yeah. I mean, so like um, I don't know what's the word for this, like robust realist or something might say, like a plenitudinous Platonist, like Ed Zolter or somebody might will say something like, for any like system, number system or whatever that I cook up, logical system, there'll be a structure there somewhere, an abstract object of a structure, and the the multiverse of structures is completely plenitudinous in the sense that like there's no gaps. Every possible structure is there somewhere. I think it's quite similar to modal structuralism, apart from the fact that I guess the modalist can at least say something like, but wait until you hear my deflationary account of what I mean by possible or something, and that rescues them from being committed to all of these things. The
Yeah,
plenitudinous
yeah.
Platonist is just going, yeah, fuck it, I'm just going to believe in all of these things or something. Um, so I can sort of
Oh, well,
understand it,
that,
but the
yeah,
connection to
that,
empirical reality still somehow eludes me a bit. Like I just sort of like there's some structure there that the differential equation is capturing.
yeah,
Whether that
right.
structure applies and is useful in calculating cannonballs, it's like yes, to some extent it is, and there might be a better
Yeah,
way of
and
doing it, which we'll discover one day. But that's got nothing to do. It doesn't invalidate the maths. I'm not interested in that when when they come up with mathematics in the first place. And you might be trying to solve a physical problem. Presumably that actually happens a lot. But sometimes people are just coming up with maths for the sake of maths, right? Like when Riemann comes up with non-Euclidean geometry, he's not doing it to solve any problems. It doesn't solve any problems for ages until somebody applies it to something. but it's mathematics before then. It's not only mathematics after, say, it gets integrated into general
Yeah.
relativity or something.
Right.
It's
Right.
just
No,
as much mathematics before then.
I agree. That's because since it's the mathematics talk is all, we'll just stick with mathematics here. Since mathematics talk is in structuralism, always talk about possible structures, it doesn't matter whether you care whether the physical structures are realized or not. You can still play the game. The game is still built to come up with possible structures and explore their attributes. But what you want to do with that, and we have, example with fiction, for example, just regular. Now, I'm not advocating nominalist fictionalism or fictionalist nominalism. I'm just saying that fiction, like I can write a story about a dragon that follows, it's perfectly logically consistent. But it doesn't require that. I don't need to care whether the dragon exists to do that. Like most fiction, most people don't care whether what they're coming up with. I mean, they enjoy just coming up with coherent stories.
Sure. Yeah.
It doesn't require the desire that it cohere, but you could analyze it. And I do this in another article regarding like Star Wars. Like there are things that happen in Star Wars that might actually be logically impossible to realize in actual physical space. And the only reason they look logically possible is because they're being realized in a studio. And so that when you understand the underlying physics of what's actually going on the screen, you can see things depicted that actually you couldn't recreate physically. But then you could recreate them in the complex sort of simulative system of filmmaking, right? And so but no one doing Star Wars gave a damn about that, right? Like no one really cares really about like when they invented lightsabers, like they weren't like worried deeply about would this even physically be possible, like that, like they just do it, right? Because it's fun. Well, isn't that neat? Like that's a possibility that we could describe and play around with and do and figure
Yeah.
things out, like and so the idea that like there are mathematicians who just like doing math, like that's no threat to my position at all. um, uh, the and it when the tire hits the road is when we're talking about, well, when they stop doing that and then start saying that, well, our conclusions in math or logic also apply to reality, then we need to start explaining like, well, is that true, and like why would that be true? And so that's the thing that we get to here. I think this really fits if we do extended Hellman, my page 2 on this. And I don't know if you're familiar with this kind of stuff so much. Um,
With Hellman a bit. I mean, I've not
yeah,
read any of him deeply, but I've read a bit of Shapiro, who's a sort of Hellman acolyte. So
yeah, right. I don't know enough. I haven't read enough to actually move around in the space between the debates between them, for example. Um, but the basic structure, this is the position I'm taking and why I'm taking it, really lines up with what he's doing. Um, so line one, like all logical and mathematical propositions, are about physically realizable structures. So it's patterns, arrangements, quantities, relations. So physically realizable doesn't mean they have to actually already be realized. It's just, is it possible? And if you did it, what would its properties be? If so, then that is necessary for logical and mathematical. All that is necessary for logical
can I
and
pause
mathematical truth.
just to
Yeah,
ask you about that first one
yeah,
before, because
good.
it's 12 points here, so I'll forget this.
Yeah, I know. No, absolutely do it. Yeah,
Um, so like physically realizable. So let's suppose I come up with some structure. You're saying that there's some question about whether it's physically realizable or not, but also by physically realizable you mean and if there's a possible structure, physical structure. So
yeah,
how wide is that possible claim there? I mean, in some sense, I think I'm losing my grip a little bit on this, but like I come up with, so let's just picture the natural numbers, just because it's easy, right? I posit this as a structure, right? I could imagine there being infinitely many things corresponding like a Hilbert's hotel, right? One door for each number in the structure or something. I mean, like that's
hmm
some way I could physically instantiate it. So, what how do I tell if I posit a mathematical structure whether it's physically realizable or not? Like, I mean, do you
yeah.
have a good
That's
enough grasp on physical reality to use that as a litmus
right.
test?
So, like,
Yeah,
yeah,
the
the
maths
question
thing.
is that that's what logic is doing, is trying to figure that out, right? The existence of it is for that purpose, to work that out. To give you an example, let's take Fermat's last theorem. So Fermat's last theorem basically took the Pythagorean theorem and asked, are there any higher power versions of this? So can you build an object that meets the definition of Pythagoras' theorem, but with the power of 3 instead of the power of 2. And for all numbers, so like infinitely many numbers above 2, is there any physical object that describes? And it took, a really long time for someone to prove that the answer is no. And the proof is 129 pages long. But what are they doing there, right? So like one, the sort of like you don't have this tool, you don't have logic, you haven't figured that technology out yet. So what do? Well, you try to build them, right? You start with power 3, power 4, and you like try to build a block that mates all 3 dimensions. And then you when you're doing it, you realize that this is not possible. I can't build, like, there's no geometry, there's no possible universe in which I could change the number of dimensions or do anything. I can't do anything. There's no each time you try to, you look at something that gets in your way. So every possible thing. Now, but of course, then you can't sit there, like if someone's sending a factory an order for these things, like find all the ones that can be built, and you go, well, it'll take forever. Like we can't test infinitely number of things. Is there a way to like cheat here? Can we like figure out by lining up elliptical curves, and there's some sort of technique that we can use to tell in advance that we're not going to find one, that there aren't any. And that's what those 129 pages do, is they show, yeah, in fact, like you can go through some structural analysis in terms of the semantics and syntax and all of that, and show that there is no object that you can build that would satisfy the factory order. That there's no thing that can have those 3 dimensions. It's not possible. And and so that's what logic is doing, is trying to determine, is it possible? And so what would make that true is just that it is not possible. So like so basically choosing the ontology that it is physically impossible to do it is the theory that explains why the result is what it is, and why the method that we're getting that result is never wrong. Like whenever we get to test it against reality, test its axioms against reality and so on, it always pans out. And then I go one step further and say, like, why would that be? And it's because it's really what we're talking about are distinctions. Once you have made distinctions, you can't at the same time say those distinctions don't exist. So if you're building a possible structure, like let's say Fermat's staircase, which every step is one of these, these blocks that you're supposed to build for every number in the number line all the way up to infinity, the staircase would never get built. And the reason is the way you can know it'll never get built is that you can actually look at the distinctions being made and show that there's no way to get that object without denying certain distinctions that you have to commit to. And so basically you're just looking at a physical system that doesn't meet the conditions, right? And if you try to build a physical system that meets the conditions, you have to violate this basic rule. At some point you have to act like there is a distinction and at the same time isn't a distinction. But of course, there either is or there isn't, right? So this is the underlying ontological reality. And the point being, as we get later on the lines here, is that if we adopt this as a theory to explain why all of this works, we don't need anything else. So like you were talking about let's just posit Platonic objects. But why? Like, you don't need them. They don't explain anything. They don't do anything. It's not like there's a God who could subtract all Platonic objects and then suddenly we can't draw triangles, right? So like we just need the possibility of drawing triangles. That's sufficient. So the physical fact that physical space can be arranged in any shape is sufficient. Like, you don't need an extra layer of reality that sort of like powers this ability to make triangles in space. And so that's the basic idea of it. I don't know if we need to go down the other 12. We can.
I think we'll be here for a long time if we.
Yeah, if we do. But what I just said just there is kind of briefing this, and the people who are watching it can screen cap it and look it over if they want. I think we should do. I'd like to do infinity, unless you've got something really you want to move to right now.
Well, I will resist the urge to respond like autistically to every single thing that you just said. One by one.
Yeah,
I think I'm still a bit confused, because I think with Fermat's last theorem, I mean, it's a theorem about geometry at the end of the day. It's not a theorem about physical reality, because physical reality
geometry is physical space, right? It's
but
all
it's Euclidean
possibilities of
geometry,
physical
though,
space.
it's a flat space. It's a triangle in flat space. It's not Riemannian.
Oh, so I don't know. I don't know if Fermat's last theorem requires non-Euclidean geometry.
No, it's
it might.
It's a theorem about Euclidean geometry. That's what it's about. A triangle is a normal triangle. I mean, it's just straightforward. Just like you said, Pythagoras
Yeah,
came
well,
up with the first version of the theorem.
it wouldn't be triangles, right? Because triangles are all described by the power of two. So if you're talking about power of three, you're suddenly talking about some other object, some other shape than a triangle. And so the question
Is that
is,
right?
do any of
Is
those
that right?
shapes
I thought it
exist?
was about what triangles.
I mean, I guess that gets into the semantics of how you're defining triangles.
Well, it's a
Like if you're saying like,
three-sided
are there
shape.
any triangles that meet the power law at power level three? That would be a really weird question to ask because it would be obvious that the answer is no.
I mean, maybe I
But
misunderstood it. I thought that's what the question was. Is it not?
yeah, no, it's actually in arithmetic. So because this was a commentary on Diophantus, who was doing the earliest first, second century, maybe third century textbook in arithmetic in the Roman Empire, and he had it. Diophantus said something about the number law, and and Fermat scribbled a thing like, well, there's nothing that meets this condition, and so that became the last theorem that people were trying to prove. It's really just an arithmetical question. So it's like a to the power of three plus b to the power of three equals c to the power of three. Does any physical shape meet that? Is there any number? Is there any? So just pick that one. We'll pick power of three, where it's all the same thing, power of three all the way across. Is there any physical shape in any geometry of any possible universe that would meet that condition? And the answer is no. There are no physical shapes that will do it. And and then well, what if we go to four? What if we go to billion? If we keep going up, are there any that satisfy it? And so when we get to the Fermat's last theorem, the 129-page proof, is showing using elliptical geometry that there's no arrangement of physical space that can produce any shape that
Yeah.
satisfies this. I can't remember if it requires planar geometry or if somehow Fermat's last theorem is false in curved geometries. I don't know the answer to that question because I haven't looked into it.
I do remember that the proof involves Calabi-Yau spaces, which are like 12-dimensional, whatever, some god-awful construction like that.
Yeah,
But
yeah.
I thought that was just somehow you have to manipulate those things in order to get the proof.
Oh,
But
I
tell us
see.
the truth
So
about Euclidean geometry. I mean,
to
maybe
see
I'm
if
just
there's any,
complete
yeah,
idiot.
I don't think the theorem requires it be a triangle, but I could see why you would think like, well, if we allow like 14 dimensions, can we get a triangle that satisfies it at power five or something like that? Um, yeah, I could see how that could be something that one's doing with Fermat's last theorem. I didn't think it required triangles. I thought it was just it required any shape or some
Okay.
shape. And I guess this is semantic distinction because if we're talking curved triangles, we're obviously talking about different shapes than planar triangles anyway.
Yeah. Right. Right.
Um,
Okay. Well,
but yeah,
let's
I think
park that because I
that's a
feel
quibble
so.
that doesn't really
Maybe we've
matter
just
to my
both
point.
got to the edge of what we understand enough
Yeah,
about
no,
that to
absolutely.
talk productively about it. But so let's, if it's all right, let's because we talked a lot about mathematics so far. And we haven't mentioned anything really about logic per se.
Hmm.
So let me just try and get us back on track with that. Happy to go and I'm not. If there's anything you want to say burningly, like just tell me at any point. I'm happy
Yeah,
to,
yeah,
want you to have your say. Um, so there were 3 points that I think I felt like I disagreed with. The first one was about um, well, whether there are. No, let's just stick to 2 points. So I think you say that you wheeled out this is a bit of a bogeyman of mine. So you weren't to know this, but like it really bugs me when people talk about the three laws of logic. It's a really
yeah,
annoying anachronistic phrase that gets wheeled out all over the place, and sometimes people who have no haven't had the good fortune and privilege, I suppose, of being able to study analytic philosophy at an academic level, right, which is like most people. Well, how are you supposed to know anything in detail about this type of stuff? And it's very commonly repeated on the internet that there's three laws of logic, and Aristotle comes up with it all, and nothing happens since then. It's a bit of a meme in the history of logic that is a thing people say, and it kind of bugs me because um, I think it's just so different from the experience of what happens when you study logic. Like if you do intro to logic in your first year, philosophy or mathematics or even economics, computer science, I don't know, loads of disciplines these days will do an introduction to logic course. They at no point will say, here's all the three laws of logic, guys. That doesn't even come up. It's not even day one that happens. and that's just because modern formulations of logic don't don't work like that. So there's it's easier and far more expressive ways of doing stuff than starting off with a bunch of laws and sort of working in a Cartesian or even Euclidean manner, like from some principles and everything else gets deduced from those things. You can do logic like that. Still people do that. It's like a sort of axiomatic approach to logic. Um, but developments in logic in the last 150 years or so have meant that people have moved away from that. So now it's more sort of model theory and semantics and stuff. So you can set up your loss, giving a bunch of vocabulary, um, some syntax rules, etc., and then starting to say things formally about like what the terms mean, right? So, for instance, if we start saying things like, I'll say, here's propositional logic, right? Give me a bunch of atomic propositional variables, P's, Q's, R's, stuff like that, right? And I'll just say there must be some function that just maps those to true or false. So each of those propositions is one of those two values and not both, and not neither, kind of thing. And then chuck in the normal propositional functions like and not and stuff, and we can just go from there. Like, right, I don't need to say, by the way, the law of non-contradiction is an axiom or anything. It's just if the function that assigns truth values in the first place is consistent, it just pops out as a theorem that for any formula, right? Any formula P, it's not the case that P and not P, it just drops out as a theorem, or a tautology, really. It's just true by definition because you state the definitions of all of the terms and stuff. So I guess I don't. Sorry, so that was just a bit of a like. I don't really like it when people talk about there being three laws of logic.
Is that one of the points? And do you want me to like respond to
Well,
that?
I assume you
before?
just agree with that. I mean, that doesn't seem like something that's worth discussing.
I do actually, but where I think the confusion is, and so I brought back up the first page. So look at the red line. So the confusion, what you've just described is how you do logic, like how the equipment we've built to do logic. But what I'm talking about is what is logic talking about? So in other words, what is logic doing? What is
Yeah.
it you're trying to get at?
Okay.
And so those are two different things. And so it's another layer of different thing if we talk about pedagogy. So like you're talking about, like if you go to a Logic 101 course, they're gonna, I mean, they're starting from thousands of years of development of logics, and then they're gonna say, okay, now I got to teach you where we are in this complex sphere of logical knowledge. What is the best way to teach it?
Hmm.
Is, it could be X, Y, and Z, but that's not going to correlate to the history of logic. So they're not going to start, well, let's
Sure.
start with all the wrong logics and then build from there. Like, they're not going to walk you through all that. You can take a course in the history of logics, but normally a logic course is skipping all that and we say, we're just going to cut to the chase. Is this where we're at now? And here's the best way to teach that to you. So that isn't going to correspond to the ontological question that I'm asking about. And I think that's the key item is like, there's certain, like, you gotta, like the way you talk about, like, go from propositional logic to first order logic and you build from there, and you got to have a certain number of separate axioms to, but that's just describing the way we have to put it in the language for us to understand it and for us to extract information from it. So that has to do with the technology, the invented technology of logic. But the question is why is the output of any of that true in the real world? Like, why is it like logic and not like chess, where chess does not describe how war or combat works in any case, right? So chess is not going, they're not even trying to simulate reality. But logics are, you're trying to get at truths about reality, something about that. And so what is that thing that they're getting at? And so that's why I'm talking about that. And when we get to my page 3, which we haven't looked at, no, page 4, which you haven't looked at yet, where I write, LNC and LOI, law of non-contradiction and law of identity. Now, to even talk and communicate on this to anyone, like, I have to use words. So I'm already in that artificial space of choosing words. So, but I don't want to give the impression that I'm talking about any particular logical system. I'm talking about what underlies all logical systems. So I'm talking about the reality itself. So we're talking about that Nantucket rule, a billion years or a million years BC, Nantucket Bay. There's no first order logic. The law of non-contradiction is not a phrase. There's no thing or anything. And yet the reality agrees with, it's either things are either the same or different, and that has consequences in terms of like the same things are the same things, and nothing can be the same and different at the same time. And so it's the same coherent, unified reality, which is just about what is physically possible there, and what structure can you build there or not build there. It's inherent in the physics of space, any space really. So this page, I think I'd be curious what I have a little side point on the bottom for the law of excluded middle. I think that's too much of a getting in the weeds of a digression. But so what I'm doing here, and I think what you think I'm doing here, is that I'm like saying that the constructions of logics today are wrong. I'm not saying that. What I'm saying is that when you look at the underlying, yeah, okay. So when I get the like as if I'm trying to tell logicians that they don't know how to structure their logics. That's not what I'm saying here. What I'm saying here is that the underlying reality that these symbols refer to entails all of this stuff. So what the law of non-contradiction describes, like what the ontological reality is that describes, it is the same thing that the law of identity describes. And on this page, I walk through the logic of the reasoning as to why that is. And from top to bottom, in terms of like, if it's true, the other one is true. If one's false, the other one also is false. Okay. And so it's like an elephant theory. You're looking at the same thing from different points of view. So one person gets a trunk, one person gets a leg, but it's really one thing. You're all talking about the same thing. And it stems from this idea that if you say everything is the same, then you are saying nothing is different. So any assertion of identity has within it already an understanding of negation. So even if, like in the way we structure things, we got to add negation later as a separate thing in order to grasp this and understand it and extract information out of it, that has to do with the mechanics of what we've invented, the tool we've invented to do that. But the underlying reality is that you can't have one without the other. Like as soon as anything, any identity relation is true, in Nantucket a million years ago, you get all the other things fall out. So like the law of non-contradiction, it's there automatically because of this basic idea that sameness entails an understanding of difference. So because negation is inherent in any statement of sameness. So I have it more worded more precisely on the page, but so that's what I was saying. And I'm talking about the ontology. I'm not talking about any system of logic that figures this out. The tools we use to figure this out is a whole separate question.
Yeah. So I think one way maybe I'll change my mind, but the way it seems to me at the moment is that when you say laws of logic, you actually mean laws of metaphysics. You mean these are ontological principles. Everything that exists and every property that it has, if it has that property, then it doesn't lack that property. Right? It's a restricted set of things we're talking about. It's existential based stuff that can.
A distinction exists or it doesn't exist. You can't have a distinction exist and not exist at the same time. I'm saying that is a fundamental ontological, that's like the ultimate law of physics. It's fundamental to all physical spaces. There's no space that you can twist, arrange, occupy, fill up, or whatever that would break those rules. And so that's what I'm saying is and all you need is the physics, like the physical, like just the fact of geometry is all you need. You just need a physical space that already obeys all of these rules. There's no way to get it to not do that. And so that's why the theory is its distinctions are the fundamental root of everything. That when people try to say that a logical contradiction can exist, they're trying to say that a distinction exists and doesn't exist. And you covered that pretty well, I thought, in your second video, talking about Aristotle, right? So I'm just saying let's take that all the way to the ontological level as a theory, and if we do that, we don't need all this Platonism stuff. We don't need fictionalism even. We don't need deflationary nominalism. We don't need non-realism. Like we don't. None of those things explain anything. We don't need them to explain anything. We can explain it all with this one theory, so that's the position that I'm arguing underlying all of this.
But look, the way you've written the law of identity the law of non-contradiction, the way you've stated it, not the case that P and not P. Great, that's a theorem of propositional logic. So, in a sense, it's true in that system for sure, 100%. If you think classical logic is just sort of true in a big T sense, true, then so's the law of non-contradiction because it's a theorem of that system. But the way you've written the law of identity is not a theorem of propositional logic. It's not a theorem of first order logic either. So that's why I'm saying I don't think that when you say these are laws of logic, why should I think that's a law? I mean, it's not a logical system that I can put my finger on. So I think when you're saying it's a law of logic, you mean for everything that exists. And when we interpret the symbol identity, you're interpreting it already to mean something. Like you're given an ontological class. Because in first order logic, and there is an identity symbol, right? But it connects referring terms, not propositions. So, it doesn't presuppose negation in that sense. I mean, like, it wouldn't make sense. Like the terms that are related by the identity symbol are not the sort of things that you can stick a negation in front of.
Yeah,
Right?
and
That
so what you're talking about are the rules that you like the semantics of this structure. So like you're choosing to not call an identity assertion of an identity relation as a proposition. You're calling it a reference or something like that.
but
But
I'm
that's
being
just the art of
differential
that's
from
the
logic.
artificial, but that's the artificial construct. Like humans invented that. Like a million years ago, that wasn't the case, right? So, um, so what it is, what so the question is what are these things referring to in reality? So if you're making like a referential rule, you can make it just like, well, this doesn't like we're just going to stipulate that A is A, right, or P is P, or whatever. We're not going to care whether there's some sort of underlying reality that describes. But then you'd have to explain why then does everything come out correct, right? Why does everything come out matching reality? So there's some sort of underlying reality. Identity relation is just the opposite of distinction, right? So like sameness and distinct. So there's differences or sameness or difference, right? Like those are physical realities, and therefore they're possibly realizable realities. And that's it. They're either the same or they're different, and then everything else follows. So this fundamental ontology explains why we have the identity relation at any point in our structured logic. It explains why we use the law of non-contradiction, and it explains even the excluded middle. Like all of that stuff is just different ways of trying to describe this basic underlying ontology. It's either
No,
same or
but
different.
I mean, forgive me though, but like in first order logic, you could express the law of identity being something like for all x, x equals x, right? Any referring term, whatever it refers to, is identical to the
And
same
what
thing.
would that then refer to in reality? What would that be a proposition about?
It depends what the domain of reference is. I mean, the logician doesn't interpret that. It's a non-logical. I mean, who cares
So
what it's
that
about? Right?
yeah, that's what I'm getting at. Is I think it does. I think it's referring to, like Hellman would say, it's referring to uh, a structural fact, some sort of structural fact that has consequences.
Right, but hold on a minute.
And
Then I
that's
was going to say what the this you can say it's a structure if you want, but then I'll nod along to that, but I'll say I'm not the logician doesn't care what the structure is interpreted to be, right? Like the number line, queue outside the bakery, whatever. It doesn't matter.
Yeah.
Something
Well,
can
they,
still
they
occupy
would
those
they would
points in the
care if they were
structure.
getting false results, right? Like they would care if this whole logic predicted things that didn't match reality. And so they say like, well, okay, so clearly we're wrong about something, right? So that's why I think whether they care or not, there is still some sort of underlying reality that they are trying to capture with that. And that's what I'm getting at. And so like, that's why you have like when you say P is P, that is literally the same thing as saying P is not P, right? Like those are identical propositions. They're
But you're
not
using
two
the word
separate
is
propositions.
there. That's not the same as the symbol identity in I mean, so what you're introducing a symbol to propositional logic, I suppose, if you're saying P equals P. That's not part of the system. I mean, that's a new
Yeah. So you're
addition. So
you're
how does
talking
that
about
work,
this.
right?
Yeah. So you're talking about the system. I'm talking about the ontology underneath the system. So
But you
for
started off
that
by
point,
saying P equals P. That's a statement in the system, but it's not a
well,
statement in propositional
I
logic.
mean
So,
that gets back to my point that there's no way for me to communicate with you without using words, right? So like I'm a slave to the words. I can't. There's no other thing I can do, right? That's why I preface that as like I'm not talking about the system of logics here. I'm talking about what underlies the logics. Now I have to use language to do that, so I can't avoid that, right? Um, but the points, the underlying ontology still matters. So like the fact that P is P means the same thing as P is not P leads to everything else. So like the law of non-contradiction just falls out of this, and so on. So all you need for logic to match reality and therefore like be useful for understanding reality is that that this describe what is possible and not possible. And so like the underlying physics, and all you need for that is physics, right? You just need a space, right? And any geometry will satisfy this condition. Like the distinction exists or it doesn't exist. And then logics are just sort of these systems we build to try and understand that and get information out of that. So it's always referring back. So even if you have like, if you want to say that the identity relation in a particular system of logic means something different than P is P, then it's still referring to something that connects back to this analysis. So we'd have to go into like, what's the difference between a P, whatever P, and P is P? Like what in what case would one be true and the other be false? Like we'd have to parse out like, what do they mean that's even different, right? What is the set of things that isn't one or the other, and not both?
I find this very difficult to understand because with like a law of logic is something that you can state in a like formally, right? I mean, the law of non-contradiction, there's no ambiguity about that. Like we know what it means. But your version of the law of identity doesn't sit in any logical system that I can put my finger on. So I just don't understand why we think it's a law of logic. It's not a theorem.
I see. See, that's now it's just now it's just a semantic debate over whether we should call it logic or not, or a law or not, or whatever. So that's just semantics to me. We could, for example, pull up Aristotle's definition of the law of identity, and it's a little more elaborate, but it reduces to the same thing. It's just that it means the same thing, is referring to the same thing, and it's very explicit to the same model that I'm talking about. That it's actually about, is there a distinction or not? And so identity is just saying there's no distinction. And non-contradiction is saying that if there's a distinction, it can't also have no distinction, and and so on. So that's the underlying ontological reality. I have to choose some sort of words to express this, and I do think all basic principles of identity collapse into this ultimately. But the way that it gets structured into a language, in formal systems, like that's the semantic technology that we invented to try and understand this underlying reality.
Yeah, but
did you do? I can't remember if you did Aristotle's law of identity in your second video.
I don't think Aristotle states a law of identity anywhere. So.
Yeah, it's in the prior analytics. Oops, that's the wrong link. Is there a chat I can plop this into? That
yeah. There's a
link with a highlight.
Right.
Let's see. Here we go. I made it go away. Here we go. Chat. There we are. Oh, I'm in the general chat, so that's for everybody.
I think that's probably fine.
If it lets me paste. There it goes. It's letting me paste. All right, so that should go directly to a translation. It even has the Greek for those who are interested. Reconstructed Greek, but
so is it the highlighted bit in purple that we're looking at?
Yeah. Mm-hmm.
So when A belongs to the whole of B and to C, and is affirmed of nothing else, and B belongs to all C, it's necessary that A and B should be convertible. Since A is said of B and C only, and B is affirmed of both itself and of C, it's clear that B will be said of everything of which A is said except A itself. Right. But that's. I mean, I don't know. I don't know how interesting this is for anyone to watch. Really, it doesn't seem to me like that's the expression of the law of identity. It's a rule of how you can exchange terms in this syllogistic logic, which doesn't have an identity symbol in it. Again, I have the same objection, right? There can't be a law of identity in Aristotle's syllogistic logic because there's no identity symbol. So there can't be a law governing how that symbol works.
Yeah. So like that. See, that's semantics.
An example.
Yeah, so yeah, you're hung up on semantics. Like, with what words should we use to describe this? I don't even disagree with you. Like there's better ways, better convoluted, complicated, obscure ways to do it that actually are much more efficient and work better in particular systems of logic. Like the way you say it, yeah, there's useful and unuseful, convoluted and simple, and all this stuff. Way that you say it is a whole separate question from what is being said, right? Like, so what is Aristotle saying there? Is he's saying if there's no difference, there's no difference, right? Like he's doing it in a much more elaborate technical way to make clear this simple point. But that is also true. This is a fundamental truth that I'm talking about is the fundamental ontology is like, if there's no distinction, there's no distinction. That is an ontological physical fact of all possible worlds. So get back to structuralism. They're talking about there is no structure that violates that rule, and there's no possible structure that violates that rule. And then the law of non-contradiction actually derives from this. You can actually show that they're actually all talking about the same ontological reality. That's shown on the page. We haven't really gone into that detail, but if you want to like go into it, it doesn't have to be today. But I can send you this document too. I don't know.
Sure, yeah, do that.
I hadn't even thought of that just till now.
But so let's talk about this idea then that the law of, because I guess we should talk
but there's
about
the interesting question of actual infinities I'd like to get to if you ever.
Sure. Okay. But let's certainly let's talk about that in a second. But whilst we're on this train, I think there's more we could keep talking about whether or not the best way of thinking about the law of identity. I mean, just for context, I think part of the thing was that up until the turning point, wherever that is, wherever you want to put that marker down in the sand, 1879, Frege publishes the Begriffsschrift, whatever. That might be the point where you say, modern logic starts here, whatever. At some point, right, we go from a phase of like pre-modern logic to modern logic. And one of the like quick thumbnail way of thinking about what that means is that Aristotle dumps this system into history, like a fully formed logical system, like 1,000 years ahead of its time. Great. And then there's some other people, the Stoic logicians like Chrysippus and a couple of other people, Diodorus Cronus, whatever. Only fragments of what they did survive. But we know some stuff about them from like commentators and a couple of handfuls of like first-hand things. And what they're saying
fragments of Galen's treatise on logic, things
right,
like that.
But the Stoic logic is more like what we think of as propositional logic now. So that's where modus ponens comes from, right? That's not in Aristotle's theory of the syllogism. So there's these two independent like origins for what we think of as logic these days. And one of the things that was really significant about what Frege did was he unified them together in a system that makes sense of both of them. And that massive leap forwards in expressive power and elegant way of like unifying those two things that no one understood how they were supposed to connect together. That is the primary first order logic, whatever, is the primary sort of philosopher's toolkit kind of thing. When we say logic, that's what we mean, unless you say something more like, oh, I mean modal logic, or I mean non-classical, whatever, something else. That's what you mean. And it just seems to me that like in that logic, that's not the law of identity, right? And that should be significant. I don't know why that's not why you're saying, oh, but who cares? That's just semantics or something. Like, hold on a second. That's the best theory of logic we've ever come up with, right? It's like an improvement on Aristotle. It's the cornerstone of analytic philosophy. You know, arguably it's cornerstone of computer programming and shit like that too. So like, it's important if that's not the law of identity in that system and it's given in a completely different way. I think that's important. And the fact is, if you take your lead from the logic and you say, what's the law of identity in this system? It's not that. And it doesn't reduce to the law of non-contradiction in that system. I mean, that's my bugbear, is that like, when you say the law of identity and you're talking about laws of logic, you mean logic in a kind of meta-logical sense, right? You'd mean that who cares about the details of
that is true.
What we're actually talking about?
You
mean in logic in some other sense, right?
Yeah, well, I think logic, like as the Venn diagram, you've got logic and then Frege logic, and every other logic is a small circle in there, right? So yeah, meta logic, that's actually a good idea to speak in those terms. It would hopefully help prevent the confusion that I'm not talking about a specific system of logic. I'm talking about logic in the abstract, which would be, like you said, a meta logic, essentially.
And you're going to bite that bullet, even though in the best, most worked out system of logic we've got, it's just not true that that's the law of identity. Even then, you're going to say, I'm going to press on and say that it is anyway. I mean, it just sounds bizarre to me. I just don't know why. What's the big deal? Why does that happen?
Right, yeah. Why? Yeah, so I mean, to me, that just sounds like a complaint in that, like, you just don't like the name. Right. So
I think something else bears that name. That's my point.
Oh, I see what you mean. Yeah, no, I'm not saying that like it was like an arbitrary, like you just like you don't like broccoli. No, I understand what you mean. It's confusing to say law of identity and mean something else than that comes from the popular system of logic that you're talking about. Um, yeah, that's a communication defect. I would agree. If that confusion is being created, I should use a different language or clarify for that.
Yeah.
So yeah, right. I mean that totally makes sense. I don't disagree with that at all. Um, the question though is like, is it important? Like you mentioned, so like the law of identity was, let's say that I've got what I'm calling the law of identity, and we've got what that system calls the law of identity. Are they actually propositionally saying anything different from each other? And we could explore that, and then we'd have to figure out like, well, what structurally is different in terms of what they're referring to. Like, are they referring to different structures or different possible structures? That's what a structuralist would pursue to see. Like, is there some other structure that we need to take into account to justify the law of identity within a particular system of logic, or is it enough to posit this structure that I'm talking about here? Does that already solve all of these problems? All of these things are just talking about the same thing. That's where the direction of the reasoning would go. Like we're not going to do that here from the armchair, but hopefully, I don't know if that like helps clear that up at all.
I don't know. I don't know that it does, because like we're looking at a formula where I don't know what it means. Like P equals P, like because you can say. I mean, look, if you say this, it's a certain sort of skeptical worries that you might have, right? Like I write down a word, like a noun phrase, right? Does it still refer to the same thing 2 seconds if I stop looking at it, or if I come back to it tomorrow, does it still mean the same thing, right? You could worry about that and then say, do you know what? I have this like worry that my references will run away if I'm not looking at them or something. I know, I'll posit this extra rule which says once I've referred to a thing, damn it, it stays. This symbol stays pointing at that same thing. It doesn't like wander off on its own or something. And that's the law of identity. It like fixes the reference and makes sure that that sort of skeptical worry doesn't happen. I mean, maybe I can sort of understand where you're coming from if that's the idea. And that's not exactly logical.
Yeah, right. That makes sense. Yeah, that makes sense. I think though. So again, it's getting to this confusion again between semantics and ontology. So yeah, let's say you have like, it's called a law of stipulation. X is just always gonna mean X. We're just deciding. So the question, like, yeah, that's a useful thing to do, and you have to do it. But the question is, why do you have to do that? So like so basically you end up with an equivocation fallacy if you don't do it, right? You end up where X means one thing in the part of an equation, it means another thing in the other part of the equation, and you've got an incoherent mess. Like you're no longer describing a structure. So to make sure that you're always describing a possible structure, you have to do that. You have to say, once X is in a particular proposition, it has to keep meaning the same thing, unless we transform it propositionally in the proposition, right?
Okay, but then I think that the statement P equals P presupposes that the reference is successful in both cases. The first P and the second.
Remember, we're in the Bay of Nantucket in 1 million BC. There are no words to refer to anything, right? So we're talking about what is true then, outside the context of any attempt that humans make to describe it, like I'm doing. I'm making an attempt to describe this property of the universe. But in 1 million years ago, that those words didn't exist, that formulation didn't exist, the structure of the logic didn't exist.
If you were
so what is the reality that I'm trying to describe? That's the difference between the words I'm using to describe a thing and the thing I'm trying to describe.
Cool. I'm happy with that, and happy to always refer to the references rather than the symbols themselves. I'm not interested in the symbols as such, but like there's something that's called the principle of identity. And sure, I don't want to say it has to be this shape on a piece of paper one day that didn't exist 2 million years ago or something, obviously. Yeah. But like, what's it doing? Let's suppose it's fixing the references so they don't run away from us or whatever. It just seems to me that even then, the law itself, whatever that is, has two things on either side of an identity symbol, right? I mean, that's how we're representing it. And but both, for it to actually succeed in not accidentally referring to, by P means me, but the other P means you. Okay, oops, I've accidentally said that I'm identical
Yeah.
to you, right? In order for it to work in the first place, we're presupposing that those references are fixed. So it just seems like it's just pointless. I don't need
Yeah.
this. If my logic was
Oh,
worried, if I
okay.
had that sort of worry,
Yeah.
no
Oh,
law would
don't.
fix it, right?
Yeah, don't need this is a good phrase. So again, that's the structure, the technology that's invented, right? Like, yeah, it's not needed for that, right? Like the logics will work fine even if they didn't correspond to reality at all. Like we don't need this. What I'm talking about to make logics work, just as we don't need it to make the rules of Dungeons and Dragons work, right? Like it doesn't. The question is what is the underlying ontology that makes us choose the difference between the rules of chess and the rules of logic. One we agree doesn't apply to reality, and one we actually do think applies to reality. We expect that there would be no real system would show up that would show our conclusions in logic to be false, even though the system of logic said they should be true. So there's an assumption there, and the question is why does that assumption govern? Like people do use logic to actually prove points in the real world, and so that depends on there being something true about the world that'll makes that possible, that transformation possible, and I think that's the issue here and it comes down to the idea of distinctions versus non-distinctions, right? So you're talking about like controlling the meaning of a word in a system of language, right? And but what that's really doing ontologically is that you're saying you can't, in the middle of a set of propositions, you can't say that there's no difference between X showing up everywhere in that proposition, and at the same time say that there is a difference, that some of those X's mean something else. And you're talking about that being like a runaway reference, right? But there's an ontological reality as to why that is, because as soon as you actually change the meaning of X halfway through an argument, you're no longer describing a structure that is possible, or at least can't be determined to be possible from the structure of logic that you've built. So there is an underlying reality here, which is that there's either a distinction or there's not a distinction, and so we just can come up with different systems of language to refer to the presence or absence of a distinction, and the rules have to match that. Right, so we can't break those rules and suddenly say that there's a distinction and not a distinction at the same time. And once we've done that, not only have we broken the rules of the system we've built, but we've also like violated reality. We're no longer talking about any real possible system, and so that's what I'm getting at, and that's why and I have to use words to say this. So that's why it can be confusing. I think the idea of talking about meta logic rather than logic might help with that in terms of avoiding the confusion between the semantic system we use to understand what I'm talking about and the underlying physical reality that these things are actually trying to capture in language.
Well, I think I think my first idea is the right one, which is that these are principles of metaphysics that you're advocating for, not
Yeah,
logic
I
at all.
wouldn't reject the label. Yeah,
Because you're
I
saying
operate on. I'm a physicalist, so like metaphysics and ontology are basically the same thing for me. So calling it the ontology of logic is no different because ontology is a subset of metaphysics. To me, it's
no,
no
no, no.
different than calling it the metaphysics of logic.
Well, I'm not distinguishing between metaphysics and ontology. I'm distinguishing between, in your view, is the law of non-contradiction a logical principle or a metaphysical principle? And there is a difference
Gotcha.
between
Yeah.
logic and
Right. Yeah.
metaphysics, on
Yeah.
your
Yeah.
view. And I think that
Yeah.
you're
I,
not
I would
talking really about logic. You're talking about
correct.
metaphysics.
I would agree. Yeah. It's a theory of why logics work, but it's not a theory of how logics work.
It's a theory about
If
what
that
the
makes
world
sense.
is like. And you
Yeah.
think that because the world is like this, that's the logic that sort of just describes the world, follows along.
But then
Right?
that's why the constructed logical systems we build work. Like why do they apply to reality? It's this. This is the reason. Um,
Okay.
that's basically what I'm getting at. And so yeah, you can call a law of metaphysics instead of law of logic. The semantics doesn't change anything there that I can see.
Well, I think it's helpful because uh, it offers what seems to me a sensible modification or distinction or something where you can say, what I'm really interested in, I think this is what you're mostly interested in, is when you say the law of non-contradiction is true, you mean, I think, I'm putting words in your mouth, but feel free to tell me
Yeah.
the right ones afterwards. But I think you mean everything that is physically realizable is consistent, right? There's
Yeah.
no inconsistencies like P and not P that could be instantiated by a physically concrete kind of thing. If possible, rather than actual, let's say, but if I can sort of understand a system or a theorem or a formula or something, interpret it as a physical counterpart, whenever I can do that, then it has to be consistent because physical reality is consistent, sort of intrinsically or something.
Yeah, yeah.
Yeah.
I mean that's sensible. The only concern I have again is there's a bit of a semantic worry that someone could take that sentence in a different sense than you intended. Um, that's why I focus on distinction. So when we say consistency, what are we talking about? And that's I'm getting at like what is
Yeah.
the underlying ontology of what does it mean to be consistent? And what it means is that you can't have a distinction and not a distinction at the same time. Once you have one or the other, that's what you have, right? And so like that's and there's no way to have them together at the same time. And from that physical fact, like there's no structure that you can describe that would satisfy the condition of there being a distinction, there being no distinction. Then that everything else follows from that. So like the idea that we can use the language of consistency and say, well, okay, another way of saying that is that only consistent systems are possible. The worry I have is that when people think consistency, they're forgetting the ontological reason why consistency is even in that sentence. But otherwise, no, there's nothing wrong with that.
Okay, uh, so then I think if it sounds to me like you can say everything that's concrete is consistent, and leave the door open for there being non-concrete, propositions about non-concrete reality, say, which could be inconsistent.
I mean, remember, possible concrete systems would have to be included in that because
Sure, but
structuralism
let's
is not
talk
possible.
about
So,
like
um,
set theory or something.
yeah, I don't even know. Well, so this does get to one point. I think we may disagree on this, which is that I do think that all successful logical systems, like set theory, they do describe possible physical systems. In the same way that trigonometry describes all triangles, set theory describes all sets, even realized sets, and possibly realizable sets, and so on. So I don't think there's it's that's why like inconsistency in set theory is disallowed because of the rules of set theory, but that also keeps set theory relevant to the real world because the real world behaves that way as well. And so that's why thinking in terms of set theory is useful because it's not just a game we play for fun. We can actually get insights about what's possible and not possible in the real world through set theory and better understand the things, the
Hold on
structures
though.
we're talking about.
Naive set theory is famously not consistent, right? Like, Russell's paradox.
Oh, I see what you mean. Right. Sorry.
Right? So
Yeah.
set theory
Okay.
is not a guide that presupposes consistency, and
Yeah,
so
but
you must say,
we've already labeled it naive though, right? So that's you know what I
well,
mean.
yeah, philosophical tradition has labeled it as naive, but also
Oh, but
it's
that
the
means
most
something
normal
though.
standard ones. You could call it intuitive set theory is inconsistent, right? You have to say something kind of weird about classes or types or Tarskian
Hmm.
hierarchies or something. Non-intuitive. It's not what you think. It's not your natural in concept of set, something that contains something else. That theory is inconsistent. So,
Yeah,
what do we say
and
then? That there's no.
that
What do we do
corresponds with
about that? Right?
reality. So like
It's
the
not
same
set theory.
inconsistencies, the same inconsistencies in that model would map onto reality and possible and actual structures in reality. So it's saying the same thing, right? So like to say that it's inconsistent is just saying that there are impossible structures described in that system, right? So it's ontologically it's the same thing, right? So that's what I'm saying is the underlying ontology of what makes the difference between a consistent and inconsistent system is whether it's referring to or describing possible or impossible systems.
But I could use naive set theory to talk about eggs in a basket or something, right? And then, cool, it's what it says is fine. It's only if I talk about sets that contain themselves that we start running into any problem. So, I mean,
Yeah.
considering physical objects never contain themselves, I could use naive set theory to talk about physical reality just fine,
Well,
and
then
you'd
you
never
get to the
notice
question
that
of
there was an inconsistency.
why is it that physical things can't contain themselves, right? Like ontologically, what are we saying there? Is we're saying that there are certain distinctions or non-distinctions that make that impossible. It's not a possible structure, right? So the underlying ontology is assumed there. Conversely, like I can correctly describe and simulate all kinds of things using the rules of Dungeons and Dragons, but like the rules for healing from wounds do not correspond to reality at all, right? So the fact that it's not a perfect fit to reality doesn't mean anything other than the fact that I can tell the difference between when it corresponds to reality and when it doesn't by whether it's describing possible or impossible or actual or not actual structures, right? So so that's why the ontology is a different question from the structure of the rules that we're playing.
It sounds a bit circular because I kind of feel like you're going to say, before Russell noticed the contradiction, Frege is cracking on publishing the Grunderschlagen or whatever it is, the book that has his theory of logicism in. He didn't know it was inconsistent. So if you were sat on his shoulder at that point, you'd probably say, cool, I like this theory. I bet it maps onto reality, explains a bunch of stuff, whatever.
Yeah.
Then Russell comes along and says it's inconsistent. And only because of that, you say, oh, well, this couldn't be instantiated in physical reality. So then
no, that's literally what
instantiated in physical reality.
That's what Russell
follows
himself
along
is saying.
whether it's consistent or not. It doesn't do anything else. You're
No,
just saying it's consistent.
That's what Russell is saying, right? And so what Russell discovered is that, this artificial system, this game system that we built, this system actually turns out describes structures that are not possible. And in the language of logic, we say, oh, that's inconsistent, so we need to make it consistent or reject inconsistent results. But that's doing the same thing. It's referring to the same ontology, that you can't have a distinction and not a distinction at the same time. So that's like the physical reality.
I don't think Russell's worried about physical interpretation of set theory. He's worried that if it's inconsistent, then it collapses into triviality and it doesn't do anything to provide the foundations of mathematics, which is what it's supposed to do. It's supposed to be a framework within which you can prove all the mathematical formulas you want. But, and this is before paraconsistency, obviously, but he's thinking, well, if it's got a consistence, a contradiction in it, then it just becomes trivial. Nothing is provable. So that's his worry. It's nothing to do with, can I use this to count eggs in a basket or something? It's got nothing to do with that, I think.
Well, you're talking about the motives, like the psychology of the person who's doing this, but that the meaning of what he's doing, like what ontologically corresponds to what he's doing, regardless of what he cares about or why he's doing it or whatever, there's still an ontological reality that corresponds to what he's doing, right? And that's why, like, if he were to find like a physical instantiation of this supposedly inconsistent structure, then he wouldn't have made that conclusion. He would have said, "Oh, well, then there must be something wrong about our method of determining what's inconsistent," right? He would slave it back to reality, even though like he would have to have run into a case of that. And I think the reason he never runs into a case like that is because he's sticking to this ontological assumption that inconsistent structures can't exist, even if he's not thinking specifically about how physical, like why that would be true physically. He's still doing the same thing. He's playing the same game, which is what structures can't exist. And what I'm saying is the reason logic then applies to reality, whether Russell cared about that or not, is because that same assumption that that inconsistent systems can't exist is it's just a physical fact. And it comes from a physical fact because you can't have a distinction and not a distinction. Once there is a distinction, there's a distinction, right? So you can't have that. I think it comes down to the fundamental physics of what is physically impossible in all possible worlds.
Okay. I think I interrupted you before you finished your point. Sorry. Apologies.
No, that's okay. I think I got to what I was saying there.
All right. So I thought maybe it's time, because we've been talking about this a little bit, about this stuff to do with distinctions and whether or not that shows that the law of non-contradiction is always true. If it's all right, I might share my screen briefly just to show a bit from, and I'm happy for you to sort of say, oh, I don't think that anymore, or what.
Let me pull mine off.
But I do want to just...
Yeah,
cool.
Okay.
Oops, I'm sharing the wrong thing here, I think.
Oh.
Boomer mode enabled. Stop. Okay, let's try that again. Christ. This is what I wanted to share. Okay, cool. So this is in your post a little bit further down. Why the law of non-contradiction will always be true. It's in that section. You quote Aristotle once here, and then you quote him again down here. And what I'm interested in is not the first paragraph after the second quote, but the second paragraph after the second quote. Here's where I took your argument to be, sounds similar to what you've been saying to me tonight, but whatever. Let me just read it out for audience or whatever. You say, for if everything is true, then there's only one thing. In other words, there's no difference between one object and another. In fact, there would then be no objects, exactly as Protagoras concluded. For to be an object requires a distinction from something else, and distinction literally is what we mean by non-contradiction. A distinction is the literal physical descriptive opposite of a contradiction. It therefore follows that in any universe where distinct objects and properties exist, where distinctions exist of any kind, no self-contradictory propositions will be true of that universe. So what it means to say that no contradictions obtain is simply that distinctions obtain. Every world and every state of being in which distinctions exist is thereby already being described as a world or state conforming to the law of non-contradiction, because saying that law is simply saying distinctions exist. Therefore, it's a description of all distinction states. So I took it that this is key to your argument of why the law of non-contradiction has to be always true, right? And it's to do with there being, as long as there's a distinction, then the law of non-contradiction is true. Is that right?
Yeah. I mean, obviously, it's just part of it, because this is deriving from the discussions before and below of what I mean by distinctions exist, right? But once you unpack all of that, and yeah.
So long as there's some distinction in the world, right? Any distinctions of any kind.
Any possible distinctions.
Okay, even wider then there's the law of non-contradiction is true. Right?
Yeah, you can call it the law of impossible structures, right? Contradictions, which would be what we were talking about earlier, inconsistent structures, will not exist in any world. There's no physical way to build them in any geometry.
But it just sounds like, I mean, isn't there a counterexample of just like, suppose there's some world where everything is completely clean and distinct and classical, apart from one proposition, right, which is Russell's paradox. And that's contradictory, but everything else is consistent. Does the law of non-contradiction, is that true in that world?
Well, of course, right? So the contradiction, so like Russell's paradox describes an impossible structure, right? So it's just asserting the same thing, that impossible structures don't exist or can't exist in any possible world. You can never realize them. That would be the modal structuralist response to that. Is that when you say that it's a contradiction, you're saying exactly what I'm saying here, is that that structure can't exist. There's no world that will contain, no possible world, no way you can arrange things.
Impossible world that can't exist. But my question is just, is the law of non-contradiction true in that impossible world? I think the answer is
because
no,
a lot. No, see, now you're confusing ontology and semantics again. The law. So let's call it the meta law, so that we don't confuse that. So the meta law of non-contradiction just is the ontological fact that you can't have impossible systems. So you can't have contradictory systems. You can't have a distinction and not a distinction at the same time. If you're talking about, can the logical systems we build can we fuck them up so that they create contradictions? Then yeah, of course. But that doesn't mean that contradictory propositions are true. It means that they're false. And that's what the law of non-contradiction means, is that any of those are going to be false propositions.
But I'm sorry, on the hypothesis, we're supposing that there's this contradiction, it's not false, it's true. And that's just enough to say, well, if that's right, then the law of non-contradiction is not true, at least at that world or something. Because there's a contradiction.
Well, if there's a contradiction, it can't be realized. And if it can't be realized, it's not a possible structure.
I mean, say it's an impossible structure if you want to, but like, I'm just saying in that world, impossible world, if you want to say so, there's a contradiction. And the law of non-contradiction says there are no contradictions. They can't
There's
both
a contradiction.
be true at the same time, can they?
There's a contradiction in the semantic system. There's not a physical contradictory thing that exists.
Let's say it's not a physical thing, and we can talk about whether it is or not. That's obviously a lot more.
Because if you could realize it, it wouldn't be it wouldn't be contradictory. If you could realize a distinction, the distinction would exist, right? So I think you're like conflating that we can create contradictory propositions out of logical systems, certain logical systems, we can realize those contradictory states in an actual sense. And of course, the structuralist would say that you can't, and that's what the law of non-contradiction means. It doesn't mean that you can't
Yeah.
have contradictory statements. It means that you can't realize them in any possible structure. So then this might get to the point you made earlier that I should be using the word like meta logic, law of meta logic, rather than the law of logic, because maybe that would help with this. So because I'm not using the language the same way that you would use it in like a specific jargonized logical system. I don't know if that helps with what you're thinking or not.
Yeah, I mean, it sounds. I think there's some degree of like talking past one another that's going on because it feels like I'm trying to draw your attention to something, and you're like going off down a different avenue instead of looking at the thing I'm saying. I don't think this is going to get controversial at all. It's like if
Yeah.
I say, imagine the statement, "There are no black swans," is true. Like imagine this. Let's pretend it's true, right? And now I say to you, now picture a world where there is a black swan. Can't be that both of those are like the general principle that says there are no black swans and this world where there is a black swan. It can't, there's something that's got to give, right? If I say you can picture yourself in a world where you're looking at a black swan, now consider the proposition there are no black swans. What do you think about that proposition? You can say from this point of view, proposition must be false because I'm looking at a black
I
swan
mean,
right now, right? Like
I
it's
you
not.
I don't understand what you're saying. Like you're talking about like empirical propositions, not analytical
Just
propositions.
just
So
as an
so like
analogy. I'm not saying they're the
well,
same.
well no, this matters because the structuralist would say that you don't have to have an actual world with white or black swans in it, as long as it's possible to have black swans, then it's possible to have black swans, right? Like there's the law of non-contradiction just would say something like you can't have a world that has nothing but white swans and has a black swan, right? Because now you're describing a structure you can't recreate. But if you say there's a world where there's only black swans and another world where there's only white swans, you can. Those are both two possibly constructible things. But if you said neither of those worlds had a black swan or had a white swan in it, or it's like that would be false, right? That's a structure you couldn't describe because you've got one world has black swans, one has white swans, so you can't say that there's no world with white swans in that case. So when you're talking about possibility space, like in structuralism, the fact that you can have like a complete nega world, like everything that's true in this world is false. I don't think you do everything, but I mean like all empirical propositions anyway. Uh, that's therefore violating the law of non-contradiction. It's not. The law of non-contradiction just talks about what are realizable systems, not what exists now. Like what exists now is an empirical question, not a question of logic. Logic controls it because actual systems are also possible systems. But obviously, if they're actual, they must necessarily be possible. So any logical system that says something is impossible for a possible system would also apply to an actual system that met those conditions. And that's why we can use logic to talk about and count on logic to be correct about the world in terms of it's a highly successful system. But we never run into an empirical refutation of any consistent logic that we use. So and when we do, we recognize that okay, that logic is giving us impossible results that can't be realized in reality. And so that's what we're doing ontologically, right? With the artificial systems that we build, the technologies we invent to try and navigate and understand all of this. So I guess I'm just not understanding where you're going with that, like why you're connecting that. The idea of alternate empirical realities with the law of non-contradiction doesn't make any sense to me. So I don't know what that's
Because I
referring
suppose
to.
I think that the law of non-contradiction is like analogous to the claim there are no black swans, because it's a universal claim and it says there's nothing of this type, right? In that sense, they're analogous to one another. Right? It's a
But it's
prohibition.
not a logical contradiction though. So it's not a
What?
logical contradiction to say that it's possible that there could have been white swans instead of
Sure.
black
It's not
swans.
exactly. It's just an
Like
analogy.
there's right, yeah.
They're
So
very
like the
different.
law of non-contradiction is just describing the ontology of possible systems. It's not dictating reality in the sense of telling us what color swans would be. Like the logic can't do that, right? Like that's not even possible.
Yeah, but it's analogous in the sense that it's saying there's nothing of this type. And in the logical case, it's saying there's nothing of this type, a formula such that it and its negation are true at the same time, right? Other than that, it's not about concrete things. It's not about
I mean,
swans.
it,
There's loads
if
of
it would
differences between them,
just
but they're both
it would
saying there's
just be
nothing of this type.
false, right? Yeah, I don't understand. Like, it's confusing a proposition being false with a proposition being contradictory. Those are not the same thing.
Look, let's think about it like this. Suppose we we are in like 1910 or 15 or whatever, and you're talking to Einstein, and he's going, thing is, there are triangles where the internal angles add up to more than 180 degrees. And you're going to go, say, what? What are you talking about? And you go, what's some like made up fantasy one? No, no, no. Real, concrete, physical ones don't add up to 180 degrees. In fact, none of them do, really. It's just an approximation. But the world we live in is not Euclidean, right? It's like that. Like you could, let's just suppose now that we're just on the cusp of some like concept mind change thing like that, where someone's going to prove that there is an inconsistency. A bit like the way no one expected arithmetic to be incomplete. Along comes Gödel, and now it just is. Too bad for those people who thought that it wasn't. Right?
Yeah, I don't see how this
What if
relates
that
to the.
happens, right? And then someone definitively shows you that there is a contradiction. So the actual world has a contradiction in it. I think you just have to say in that circumstance. I don't know how you would have got to this point, right? How your mind would have been changed like that, but
That's
had
not
it
how that
been
works at
changed,
all. I don't understand.
Hold on, let me just finish the thought.
Okay,
Had
yeah.
someone presented to you, like you might not have expected arithmetic to be incomplete, but Gödel just proves it. Too bad, right? You might think there's no way that there could be a violation of the law of non-contradiction, but let's just suppose, for argument's sake, for fun, that somebody like Gödel shows you that contradictory, an unintuitive result like that. I just think that, like, all I'm saying is if that happened, you would go, well, because there's a contradiction now, even though everything else in the world is the same, cups of tea are still not cups of tea, etc. Everything else is fine, but there's this dusty old contradiction in set theory, right? You're going to say the law of non-contradiction, strictly speaking, isn't true, right? It's true of everything I can touch and taste and whatever, concrete stuff. It's just not universally true because there's a contradiction. So that's all.
Yeah,
It just seems to me like that's
no, it
enough.
doesn't
All that
make
you
any
need to knock
sense to
out
me.
the law of
Okay,
non-contradiction is one contradiction. That's all my point is.
but
Just like the only way that you can knock out the claim there are no black swans, not with like shitloads of black swans, just one is enough,
yeah. So
right?
like the thing is like the there's no contradictions in Euclidean geometry. So saying that they're like so if you come to we actually knew we had spherical trigonometry already in the first century AD, so it wasn't really a big super surprise that you can have triangles that don't add up because there's different rules for the summation of triangles on curved surfaces. This was Roman cartography. We've had that ever since then. But it hadn't been formalized into a Euclidean-like proof system. That was the first thing that got done. I don't remember when that happened, but it's sometime in the modern period. But the fact that Euclid was describing planar systems might not have been like explicitly stated, but when we discover that, oh well, if you this, if you work in a curved space, Euclid's system no longer describes that space. That wasn't a contradiction. That was just discovering that Euclid's system only applies to planar states. There's no contradictory system in the world that actually is being realized. The world is perfectly
Yeah.
consistent in both cases. So the idea that yeah, if you take Euclid and then apply it to curved spaces, you get inconsistencies, but that's a product of the artificial system Euclid built. It's not a property of reality.
I'm
And
not saying
our response to that was correct. We said, oh, okay, so what we need is a non-Euclidean geometry, and to make sure that Euclidean geometry, that we only realize that only describes structures in planar space. That was the thing that we did. And so that was why, again, we're conforming our mathematics to reality by applying the principle what is ontologically the case, because if Euclid's system is describing contradictions, now we know it is no longer tracking reality. So we had to go, okay, so we have to make sure that Euclid only describes structures in planar space. And so you make that decision, and now it becomes consistent again. And then you say, well, okay, now we got to deal with curved spaces because now we empirically know about that. So we're going to develop, spherical and non-conformal trigonometries and so on. And so and then in order to make that consistent again, right? So like there's no violation of the law of non-contradiction there. In fact, the law of
I'm not saying
non-contradiction is
that. I
what.
think you've missed the point of the analogy somewhat.
Yeah, that's
I
why I
wasn't
really do
saying
think
that.
I'm not getting it. I really don't
I'm
think I'm
not
getting
trying
it.
to say it wouldn't be an analogy if I was saying Euclid's geometry is inconsistent. I would just be saying here's an actual contradiction or something. I'm
Well,
not
it's
saying that.
inconsistent with reality, you were saying, right?
No, I was just giving it. I gave two examples of just like a Gestalt shift. That's all I'm saying. Is like
Yeah,
it
yeah.
doesn't matter
I just don't.
what
I
the
just don't see
example
what that
is.
has to do with
Because I was just
non-contradiction.
trying to get you over the hurdle of like, what if there was a contradiction that was true, and it seemed to me you were going, well, there couldn't be or something. And I'm
Well,
just saying,
your
well, that's
example shows that.
easier.
We
Just pretend with me
we
for a
know what
minute.
happens. We reject the logic because we observe and see the system doesn't exist and can't be constructed.
Right, but
So
that's sort of like digging your heels in. Like if I was to say to you before Riemann, imagine a triangle with angles that don't add up to 180 degrees, and you go, well, that's just a sign that you've drawn your triangle wrong or something because they all add up to 180 degrees. That's just digging your heels in and refusing to sort
well,
of
and I
imagine
would
it
be
being
wrong,
different.
right? That would just be a false statement. That's not a
Right. So,
contradiction. That's
so for
why
the
I don't see
purposes
why
of
that
the thought
applies to what we're
experiment,
talking about.
the purposes of the thought experiment, though, just go with me.
I
Right?
just don't
Imagine there's a
understand what
world
it
where there's a
what
contradiction.
the thought experiment does. I just don't see what it accomplishes. Sorry, I'm completely missing your point, I guess.
It's really, it's there's nothing deep about it. I'm just saying, imagine there was a contradiction, right? Whichever one you want, doesn't matter. It can be some set theoretical thing, whatever. I'm just saying, don't worry about anything else apart from just a simple thought. Is just that if that was true, even if you think that's impossible, just go with me for the purposes of the thought experiment. If that was true, the only thing I'm asking you to concede is that the law of non-contradiction is false because there's a contradiction. That's it. All the law of non-contradiction says
Well,
is there are no contradictions, but here there is a
no,
contradiction, so
yeah,
you
no, no,
can't
no,
be
no,
that it's
yeah,
true.
yeah, no, 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 no. The law of non-contradiction says that contradictory states of affairs cannot exist. So it's not a
Right.
statement about systems, of artificial linguistic systems. It's a statement about reality, right? So the whole point is like if we get a contradiction now, let's say Euclid, there's a contradiction there, and then we go and actually build the system that's supposed to be contradictory, and lo and behold, we actually can build it, and it's possible, and it is inconsistent. That's what we would need to believe that the law of non-contradiction doesn't describe reality, because then we've got, oh, now there's distinctions and there's no distinctions at the same time, and we've created it, we've done it. And so the fact that you can never do it, not only like empirically have we never done it, but you can work it out, like for Ma's last theorem, you can work out why we can never do it, right? Like you can show like, well, there's no possible geometry that would be realized, right? Like you can't get triangles on a curved surface to align with Pythagorean's theorem, right? Or at least with the trigonometry, planar trigonometry, or whatever it is that you're doing. The empirical reality always verifies the principle that impossible systems, systems that have distinctions and no distinctions at the same time, inconsistent systems are not possible to build in any possible space. So that proposition is constantly confirmed. Like we've never disconfirmed that, and that's why it's a pretty strong theory. And then once we have that theory, we don't need any of this other stuff, the Platonic mathematical objects or any of that other nonsense. We don't need that to explain why logics work. We don't need an actually infinite universe to talk about the possibly infinite universes, right? In terms of what is the structure, what would be true of that structure. We can do all of that because of this principle that distinctions are distinctions, and there's no way to have a one distinction and not that distinction at the same time. You can't have a swan that is all black and all white. There's a fundamental structural reason in space-time, in any kind of reality, as to why that can never happen. Because you're, in the one sense, describing the existence of a distinction, and that literally is the absence of there being no distinction, right? Like this, it's the same thing. So that theory is very, Occam's razor. It's extremely simple theory because it seems to be practically self-defining, and it can be true of reality. We've observed it to be true of reality, and it explains everything that we need to have explained about why logics work in the real world. So we don't need any other thing. We don't need Platonism or any of that other stuff.
Uh, I'm struggling because I don't understand what's so difficult about saying. Yeah, you lost me. I've got to say, like, I'm
Yeah,
trying to like
sorry about that.
keep the communication aligned here, but like, it's hard because At what point do we diverge? So the law of non-contradiction says there are no contradictions, right?
No contradictory states exist. Yeah.
That there's no proposition
Contradictory.
P and its negation that is both true, right? Can we say it like that?
So you're talking about propositions. Remember, I'm talking about ontology. So I'm talking about the behavior of reality, which we can formulate as a proposition, right?
Well, what
So
about, are there propositions that are not about like that? Right, because you just made a distinction. You said, well, you're talking about propositions. I'm talking about things that exist in reality or something, right? Are there propositions that are not about things that exist in reality then?
yeah, of course.
Okay,
That's why possible structures. Yeah, possible structures. So that's why I was talking about, like, you take any like finite space, and the possibility of growing it into an infinite space. That's a possible structure. So you can talk about that without actually having to do it. And anything your logic came to with that would be true of the alternative infinitely wide universe.
So by possible, what do you mean by possible? It's a possible structure in virtue of what?
Realizable. So uh, that yeah, basically just that, like realizable. Like it comes down to this idea of distinctions. Once you've established that there is a distinction, that ends all argument. Like, you can't have a distinction and not a distinction at the same time. It's one or the other. I'm saying that is the ontological fundamental reality. There's no physical system you can ever build that will violate that rule. And then we can talk about
how
that,
do you know that?
formulate propositions.
Which thing comes first, I suppose, is my question. It's like,
well, we know it. Oh, I see what you mean.
The
like
law of non-contradiction
is
the law of non-contradiction seems to me doing work in your understanding of what's possible and what's not. In which case, it's not useful as a way of deciding whether the law is true, because it sort of presupposes it.
Well, right? No, because we can observe, we can test it, right? Like, I've discussed several tests we could run, so we test it all the time.
Look, if I say here's an inconsistent system, like Bohr's theory of the atom or something, right? It's not so straightforward that you can say to me, the reason we can tell this isn't true is because we can test it. I mean, it's quite well supported empirically, but it's inconsistent assumptions.
I mean, a better assumption, a better analogy would be the like the law of gravity or something, right? Like something that we've tested a zillion times, right? Like, so like every possible effort to build an impossible system has failed, right? Like, we build an impossible structure. So a contradictory structure, we can describe infinite numbers of contradictory structures. We can attempt to build them in the real world, and we always fail. And not only do we fail, we can see why we will always fail. And that's why we get like Fermat's last theorem and the 100-page proof is you can show geometrically, you can show with the principles of geometrically, is that once certain things are the case, other things are not the case. Like, that's just it. Like, there's no deeper level of, there's no like demon who's making this happen. There's no way to have a world that wouldn't be happening in, right? Like, the description is actually stating the fact of it. So that's why when we're saying like you can't have a contradictory state of affairs, is that nothing is being described when you do that. Like, if you say that cat is all white and that cat is all black, you've communicated nothing about what color the cat is, because you've said that it's white and it's not white, and that's completely useless information, right? And that's because you can't build these systems, like, and so you can show that you can't build them even when you can't physically attempt to build them, and that's what you get like Fermat's last theorem. The proof of that shows that when you follow certain geometric structures, you can prove that there's just the lines don't meet. There's just no way to get these curves to line up, and that means that there would be no way to do it in the physical world too.
But like Bohr's theory of the atom is an interesting one, because it does seem like it could map onto reality, and our reasons for rejecting it are not.
Yeah, all false theories.
Just because
geocentrism mapped pretty good to reality when Ptolemy was building his system. There's no problem with having false theories. Like the fact that you have a false model.
But it's an inconsistent theory that's well supported empirically. That's the point. It's like, it's not just that as soon as you have an inconsistent theory,
except it was
glaringly obvious that it doesn't apply to reality.
I just don't see the problem. If inconsistent theories are always proved false, then there's no problem for what I'm saying. Like, we would need to find a concrete example of a logically contradictory system that actually existed, that we could see, like, holy crap. That's the only way to falsify this, right? On the other side of that, we've got 15 gazillion trillion verifications of it, right? So like the prior probability of it being false is like astronomically low, like beyond astronomically low, based on the sheer number of observations that we have here all on one side, and no counter observations. Like it's one of the most thoroughly proved laws of physics that we have, if you think of it in terms of a law of physics. So there isn't any really, I just don't see, and so it sounds like you're trying to present me with an example of this, of there having been an actual contradictory
No, I
system
think that's
realized.
so. Listen,
And
I think that
and
the
what I'm
nuance
saying is that
between-
that can't happen, and the fact that it can't happen is why logics that assume it can't happen are why they work, why they're actually useful for describing the world, because they actually match the ontology of the world in that basic level.
Okay, so listen, I'm not saying I'm going to defend dialetheism and my example is Bohr's theory of the atom. I'm not saying that. What I'm saying is I don't buy that it's obvious that you can just tell by looking at a theory, oh, look, it's inconsistent, therefore it's not possible. I mean, and that's why the Bohr example is useful, because on its face, it looks like it is possible because it's well supported empirically. It's not a glaring
Yeah, but
hamburgers
that's not a
eating people kind of craziness. It's a
but that's not a
realistic
logic.
plausible theory.
That wasn't arrived at by logic, though. That's not a deduction from logic. Like you're talking
But
about
it's an
empirical
inconsistent
hypotheses.
structure. And I was asking you, listen, so you said
But
that all
so yeah,
possible systems.
but it's
Sorry,
false.
just give me-
Is my point. Is that you can make that point? Is like, okay, look, the system's inconsistent. Therefore, Bohr's model has to be false. And guess what? We verified that. We're right. Logic was correct. Inconsistent systems cannot be true.
Well, I don't know if that's true. I mean,
So
is it
his
true
model
that
was incorrect. So the fact that his model was incorrect doesn't violate the law of non-contradiction. It actually verifies it, because the law of non-contradiction says that if his model of the atom was inconsistent, then his model of the atom has to be wrong, because there's no possible structure that can satisfy his description. So
all I'm saying is it wasn't obvious at the time. Otherwise, he wouldn't have got
that's
off
an
the drawing
empirical.
board with it.
Yeah, that's an
So,
empirical
but
question.
your claim is
Even
that you can tell what's possible just by asking if it's consistent or not.
no, I can be wrong about things. So like I can look at Fermat's last theorem, and classic example, there were many proofs of Fermat's last theorem that took a lot of looking at to figure out that they were incorrect, that they were not successful. And the one that is deemed successful won the Nobel Prize. That one could yet be incorrect. Like there could be 1,000 genius mathematicians have pored over it and confirmed that it's valid, and all of them were mistaken. Like this has a non-zero epistemic probability of being true. So it's entirely possible that Fermat's last theorem is false after all and not true. So, but that doesn't violate the law of non-contradiction. It just means that we were wrong about a thing.
Yeah,
see what
but
I mean?
I'm not saying that. So, let me just try and take a step back, because the reason I'm going down this line of arguing or questioning is that I have this sneaking suspicion that it sounds to me like when you say the law of non-contradiction covers every possible world, right? But by possible, you mean worlds that could in fact be possibly or actually whatever. By possible, you mean physically realizable. But so how come? So I say, well, what reason have you got for thinking that naive set theory couldn't be physically realized? And now it sounds like you're saying, well, because it's inconsistent. But then that's just a circle, because
No,
like,
no,
I'm
I
asking
said
you
if
why
you-
inconsistencies are impossible.
All you got to
get
do to
that.
test, no, all you got to do to test that is build some inconsistent structures in the set theory, and then try to realize them in reality. And not only will you fail, that's the predictions. This is the prediction of the hypothesis. You will fail every single time. But when you try it, you will realize why you're failing. And therefore you'll start to realize you could actually explain, like in Fermat's last theorem, the proof of that, you can explain why you will always fail. Like you don't even have to test every single possible inconsistency to see that the inconsistent systems are not physically realizable. So you start to see, and so we start with that as the hypothesis that explains reality and explains why logics describe reality. And we've tested it 1 billion times. And so there's no need for any other theory. Like we don't really need any other ontology to ground logic than that. We don't need to resort to Platonism. It doesn't do anything. It's useless. That's the point, right? Like, so it's it's like I said, it's a testable hypothesis. It's verified and multiply verified. And so
You
to
think it's a
falsify it, we
priori
would need. What's
Or
that?
is it a priori, the truth of the law of non-contradiction, or is it a posteriori? Do we learn it only through observations, or
Well,
is it
yeah, I
known through reason?
all knowledge I think is posterior, right? So, which is why like not everybody realizes what we're talking about. It's not self-evident, and it's a hypothesis. Like you're saying, like we can construct the idea of an experiment, like an inconsistent system, and then physically realize it. So there is the potential to falsify it. So it can't be a priori. At least so far as I know. If someone can actually produce an a priori demonstration of it, that would be interesting. But I'm saying I don't need to do that. The point is this is a posit that explains a bunch of stuff. It's 100% successful, like massively statistically successful, and it eliminates the need for other explanations for what logic is doing. And that's basically it, right?
But if it's an empirical hypothesis, um, then you shouldn't say uh, big statements about every possible structure or whatever, because
Well,
that's
that's
the
the
sort of thing you would say if it
hypothesis.
was a principle.
That's just restating the hypothesis. The hypothesis
Yeah.
is that inconsistent structures are not possible.
In
And if
virtue
we
of being a
accept that as a
hypothesis, though,
fundamental,
you're
if we fa-
accepting it could be false, right? So
if we
in which
accept that
case,
it's a metaphysical law, I myself personally cannot think of any possible way to refute it. Like I can't build a model in my head that would be realizable and violate the principle,
yeah,
which is further evidence, right? Like sorting through all possible structures in our heads is part of the evidence base for this, but also trying to do it in reality, also trying to do it in formal systems like the Fermat's proof or the proof of Fermat's last theorem. Like all of these are empirical tests to see whether are these physically realizable systems, and finding that the answer is no, right? And um, so really, and like I said, like the evidence is stacked so high that the probability that we're wrong about this is in the same vicinity as the probability that we're victims of a Cartesian demon who's tricking us into thinking all of these things because it has electrodes in our brain and it's fooling us. Like this conversation isn't really happening. Um, like that requires like a massive number of assumptions that all have very low probabilities, and so when you stack them all together, it's the least likely explanation of what's happening between you and me right here, right now. But it doesn't mean it's impossible. It could be happening. It's just we have no reason to believe that it is, right? And so the same thing goes with like is there some other ontology that grounds why logic is successful? I don't know of one, right? So like, we don't need it. Like we don't need the Platonic object theory doesn't really do anything. And you can show that it's not necessary, right, for explaining why logic works, why math works, and stuff like that. I mean, we don't need a special planar existence of Plato's forms in order for triangles to obey the Pythagorean theorem, right? We don't need the extra layer of stuff. The physical reality, geometry, the geometric space is enough to ground it. Like we don't need anything more than that. And so yeah, that's a hypothesis. Maybe we could be wildly wrong. It's just very unlikely that we're wrong. So like entertaining the possibility we're wrong is worth doing philosophically, but trying to act like it's a 50-50 proposition and we should be agnostic about it, I don't see how that follows at all.
yeah. I mean, I think it's one of those questions that's really difficult because I think the grip on like when you're talking about when you're like it's like I guess it's hard to like the boundaries between like when something is sort of running up against the limits of your language and when it's running up against the limits of reality itself. It's really hard to know which one of those it is, and also it's when you're running up against the limits of your own cognitive scheme
Yeah,
or
yeah,
whatever,
yeah. That's
right?
that's why
Because like
proving Fermat's last theorem took 129 pages.
right,
So yeah,
but
it's often
I'm
difficult.
thinking of
Yeah.
like Kant says something about how uh, Euclidean geometry is a transcendental. Oh fuck, what's the term for when a necessary a posteriori? Is that right?
I
Necessary.
don't know.
It's that category that he comes up with to get around Hume, where it's like it's necessary, but it's only about my internal conceptual scheme or whatever,
I see.
right?
Yeah, yeah.
So
I'm
it's
not
about
familiar
how I
with
have to
Kant's.
conceptualize the world. But the
Right. I'm
point
not
is that
familiar with that. So
whatever, it doesn't matter. The point is that Kant says it's inconceivable that Euclidean geometry is wrong. It's built into our hardware of how we think about the world. But that's not true because you can train yourself when you study non-Euclidean geometry to just drop that. It doesn't matter anymore. So like, I just sort of worry with these types of things where you're well, I don't understand how there
yeah,
could be one. Isn't that just
so
like
that's actually
that, you know?
that's not a valid falsification test because Euclidean geometry is not inconsistent. It's just planar. So it's completely consistent, and it was just basically everybody was operating on the hidden premise.
Yeah, I'm not saying it's inconsistent.
Hidden axiom of planar. Yeah, but that's what I'm saying is like if, like it's not like you can refute Euclidean geometry by presenting non-Euclidean geometry. All you've done is prove that there was a hidden premise in Euclidean geometry, so the consistency is maintained. Now, of course, the Kant's idea that like trying to reduce everything to what's going on in your mind. I know I don't think that's a useful direction because you need to know what's going on outside your mind, and if logics are not successful in determining that, we should get rid of logics or just relegate them to games and puzzles magazines and no longer fool around with it. But if we're going to use logics in any sense, and as we have to do for our ordinary life, for scientific method and all of that, we really need to be sure that those logics are tracking reality, that they actually are telling us things that are, trustworthy about reality. And so that's why it matters that Euclidean geometry is not inconsistent as long as you realize that everybody was operating on the assumption that it was planar. Once you get spherical trigonometry in, well, then all the game changes. But now we're talking about a different thing. We're talking about different structures than Euclid's system was designed to talk about. And I think that actually helps us improve logics and mathematics by realizing that what we're trying to do is build systems that can tell us what structures are physically possible and which ones are not. And that does depend on this assumption that you can't have a distinction and not a distinction at the same time, like as a fundamental physical law, that's just the nature of any physical space. And so if we adopt that hypothesis, then it all works, and we don't need anything. We don't need any other thing, right? So that's I guess really just the sum of what my thesis is that there's no reason to go to these sort of theistic models or Platonist models or even fictionalist models. Like, we don't need those. We can actually talk coherently about all of this stuff using a modal structuralist approach. Like it's sufficient, right? It does everything we need it to do, and it explains all observations to date. And so why should we believe anything else, basically?
Okay, well, we've gone over it a lot, so I guess we're not going to resolve anything. So let's just
I get, and I think the audience, they've heard both our positions on this, so I think hopefully they can extract something useful out of it too. So it's worth having gone rounds about it. So,
for contrast, I suppose. Actually, first of all, let me just let my dog out of this door because she's.
Oh, okay.
Yeah. So, for contrast, I suppose let me just say that where we disagree, at least some places where we disagree, I think and by the way, if there's anyone who's got any questions and you want to type them in now.
Yeah, I think that's, I was going to do a whole thing about infinities, but we don't need to do that. Like, I think,
or we can do that the main whilst people are coming up with their questions. What were you going to say?
Oh, no, I don't want to create all these rabbit holes. We've already gone like 2 hours, so we probably let's let the Q&A happen. Let's let anybody, if they got questions.
So I was just going to say, look, for contrast's sake, like I don't think that logic has a connection to physical reality in the same way that you do. So it might just be a wider philosophical perspective or something. But people used to think that logic was about how the mind worked, right? And it used to be all about the laws of thought and stuff. And then another change that was instigated by modern logic was that we stopped thinking like that. And the way you talk about it makes me think that this is a vestige of that sort of thing. Where it's like people are going, logic, it's not about thoughts, but it is still about some specific domain.
Yeah, if we put the word correct thought, laws of correct thought, right? Obviously, they're not laws of how we actually think. We're actually really crappy thinkers. That's not innate to us at all. These are tools we had to learn, basically. So laws of thought would mean laws of correct thought. I always took that as just an implied statement. I never took the word laws of thought as referring to some sort of theory of neurophysics or human psychology or anything like that.
But nonetheless, that was how people talked about it, like
Yeah, right.
Leibniz or whatever, right? They did think that it was something universal about how thought happens, and it's not like a million miles away because we think of it being something like to do with reasoning or whatever, and that's something that our minds do. Anyway,
Yeah.
we no longer modern logic doesn't think that logic is a branch of psychology or anything to do with
Yeah,
how the mind
right.
works directly, right?
And
And
I'm
I think
100%. I agree with that. Yeah,
we agree on
absolutely.
that one, yeah.
Yeah.
But then where I disagree with you is that from my perspective, and I don't expect you to agree with this, it feels like you're doing that thing that the psychologists' account of logic used to do, but changing it so that it's not looking at the mind, but it's looking at some other thing. Whereas, from my point of view, logic is autonomous. It's just about its own thing. It's not about anything else. It's not like second order related to what's physically realizable. It's just about what logic is about. It's its own thing. So that's just a point where we disagree, I think. And maybe it's because you have a wider sort of physicalist program or something, and I don't. So
Yeah,
I
my
don't.
my
You know.
yeah, my ontology and epistemology are clearly very different from yours in that regard. Yeah.
Okay, cool. So on that bombshell, I don't know if there are any questions. I guess I'll scroll up through the chat. Jake is saying my first super chat already disappeared.
Oh no.
That is annoying if that's right. You can write it out again. Obviously, don't pay for another super chat. What is the point of these super chats if they disappear?
expire? Yeah, that seems dumb, right?
So I can't see it either by scrolling up. But Jake, if you want to
Yeah.
ask it again, I'll
Wait,
certainly
wait, hold
answer it
on.
and try to.
Are they colored? Oh no, never mind.
Yeah, they are, and it's
But
like
I don't see the
jumps
color.
out. It's completely different.
Yeah. Oh, that's annoying. Damn.
But he may have also got bored and stopped watching the stream and might
Oh
not
no.
even say this. But,
Well, let's see. It might not be too far up. Let's see.
there's a typical guy in caps locks saying stuff about
Somebody's
Jesus.
somebody's pulling something. Okay. Did it?
All right, Cam is reproducing it. So the
Oh, good.
question is something like, "May I ask Carrier's opinion on priests' dialetheism? If there's time for a Q&A at the end."
Yeah, I don't. So I haven't studied that enough to have like a competent opinion about it.
Okay, fair enough. Okay, great. And so modern atheism says for Alex, can we demonstrate the law of non-contradiction starting from the definition of the word not? I think you can't really. I think what you need to, the only way that you can, the only meaningful sense in which you can demonstrate the law of non-contradiction, I think, is a sort of trivial way, where once you've got classical logic, I will deduce it in the normal way. Right, that's it. But because you've had to give me classical logic first, it's not interesting because arguably it was built into that system in the first place. So I don't think there's a meaningful way of demonstrating it. I think it's trivially demonstrated. It's a bit like Carnap, right? Rudolf Carnap, this early 20th century logical positivist guy, has this distinction between internal questions and external questions, right? So from within a system, give me classical logic, and now I can say within that system, the law of non-contradiction is true. You give me some non-classical dialectic logic or something, and I'll say within that system, the law of non-contradiction is not true. Easy. In each case, the internal question is sort of trivially easy to answer. And then if someone says, well, what is really true, though? At that point, Carnap just goes, what are you even talking about? That's like a meaningless question. And that's basically the origin point for logical positivism, is that you're going to say those sort of external questions are literally meaningless. Like there's no answer to that question. The question is not even well formed or something. Now that's a bit extreme, I admit, but it does seem to me that there's something about that seems sort of plausible at least, right? Like it's sort of trivially easy to say within this system this property is true. And now the question about, but independently of that sort of metaphysical question, is sort of like dauntingly difficult to answer, that I'm tempted to think maybe this is just somehow a scrambled question that doesn't even make sense or something like this. It's tempting, at least. I don't have a particularly settled view on this question, so I'm not sure that's even helpful. But I don't think you just have the word "not" and uh, demonstrate that the law of non-contradiction is true anyway. So I suppose in that sense, the answer is no.
Yeah, I would. I pointed out earlier in the stream that to say that something is the same thing as understanding what it would mean for it to be different. So to say this is the same as that entails understanding they are not different, right? So like negation is just already inherent in any kind of discussion of distinction, its presence or absence, right? So it's just there's no way to like separate these out, so they just come together, and in any physical system is just the case. Uh, but so yeah, that's to say everything's the same is to say that nothing is different, right? Like so that you've always got that. The negation is just inherent, and so you just have to extract it and then put it into a semantic system that you can use to build propositions and languages in language to talk about reality. So that's would be my answer to that. I noticed Jake put up his other thing. His larger point was, what if there are true contradictions in reality as there are according to Priest? Now, is this an example like contradictory legal systems? Was that one of his examples? I can't remember if that's where I.
That's one of them. Yeah.
Yeah. Sure. So, I mean those are contradictions in semantic systems, right? Which obviously can exist. Like Lewis Carroll was very fond of this, or very fond of writing these kinds of things. Yeah, contradictory fiction, contradictory statements absolutely can be written. The question for the structural nominalist is to say, can they be physically realized? So a legal system is just a set of rules or procedures. So it's not describing a geometric structure. It's just describing the reality that there are systems that you have no answer to the end product of what you do, and you have two different instructions and they contradict each other. So you're talking about not physical contradictions. You're talking about structures that break at some point. And you can do this with programming too, where you have Go subroutines and so on that result in crashing because of a contradictory command. So those things can exist, but they're realizable in the sense that they don't work, right? So like it actually confirms the point that the contradictory system doesn't work is what it means to say that you can't have that system. You can't have a contradictory system realized. The system has got some sort of goal and it's not realizing it because it's broken. I don't know if that like captures the whole point of Priest though. So what I'm going to do is I'm going to go read up on that. And I'll definitely blog. I'll do a blog about this stuff at some point. It'll probably take a while. But I'll see if I can include some more coherent and thought out comments on that.
Yeah, I would recommend reading a bit of Priest. All my books are packed away, so I can't pull any out to show you. But his main...
Jake's bringing up the point about fictionalism in social ontology and things like that. I'll look into that and I'll write something more better. I'll give you a better answer on my blog at some point.
Okay, so just to help chase you, or before you've even started writing that position, then and see if I can scare you away from what you wanted to say. Anyway, the thing with that, it's true, obviously, that the example of legal contradictions, and particularly heavyweight metaphysically, that there are other examples of that. Priest's got this really fun book called Beyond the Limits of Thought, which I would say is a good way of getting into it. His main tome on contradiction is called In Contradiction, which is also an excellent book, but it's really difficult. So I mean, like, have fun with that, but I wouldn't expect you to sort of plow through that and have an easy answer at the end. But anyway, read Beyond the Limits of Thought, because it's a little bit more pick-upable kind of thing. But look, I agree, right, that it's not the most metaphysically heavyweight thing in the world, but there is a sense in which it's true, right? If Congress passes a law that says that you can smoke weed or something, right? Now it just is true that you can. It's a truth, right? You can say, well, it's not a structure, it's not a blah, blah, blah. That's fine. I agree. But it is true. And you might think, anyway, and here's the sort of introduction of the challenge, is you might think, well, it doesn't count as the type of truth that the law of non-contradiction governs. Because you might say, well, it's just a social constructed blah, 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 whatever. So you're introducing some clause which says the law of non-contradiction covers every proposition of this type. And now it's a promissory note because, like, what exactly is the type that you're talking about. If it doesn't cover the legal cases, there's something wrong with that example, something about structure, something about ontology, blah, 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 you have to cash that out, because unless you do, it does look like at least a prima facie example of how there could easily be a contradiction realized in the world. I mean, it could in fact happen tomorrow that Congress passes two contradictory laws, in which case it would be seemingly in a naive understanding, at least of the semantics or something. It's both true that you could say can vote for this in this election, and not true that you can vote, because the law says as long as you bring your ID, but the law says even
Right,
if you
yeah.
bring your ID, right? So
It's
that's a
yeah.
contradiction.
That's okay. That gets to contradictory commands, right? They cannot be realized. You cannot fulfill the command. Yeah, that's the
It's not so much
structure
as
that
a
can't be
command, it's
realized.
true. Isn't it true that
So
you can smoke weed? Is that a command?
well, I mean, first of all, it wouldn't work in American law. So like, if you passed a law saying it was legal and then immediately passed a law saying it was illegal, the later law would supersede the other law, so you wouldn't have a contradictory thing. More plausible would be if they changed the system and said that it is both legal and illegal, and fuck it, that's what we say. And then the command would be unrealizable. There would be no way to fulfill the law, right? It would be impossible to obey the law in that particular case. So 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 unrealizable commands is different from like the ontology of commands is,
Mm.
are they realizable, whereas the ontology of hypotheses is that they're, you can actually go get them, like you can go.
Okay, but that's my point, is that you have to tell me some story about why
Yeah,
that doesn't count and this one
yeah,
does.
yeah. No,
And
I
it's
think
like
like
a
that's
whack-a-mole example where like we can talk
oh no,
about
yeah.
different examples and it starts
Well,
to
no,
become
the
very
reality
difficult
has
to
a very
tackle
broad
them.
furniture. Like we're going to have different, like the way commands. What is the fulfillment conditions for a command versus a hypothesis, right? Obviously, because commands are different from hypotheses, so you're going to have to come up with an explanation of what are they're going to be different. Like the fulfillment conditions for a command, fulfillment conditions for a hypothesis are different, and so on. So that's not a problem. Like obviously, reality is complicated. There's lots, so you're going to have to come up with an explanation of every weird thing. There's going to be something you got to get at. What is it actually describing, and what does it mean to realize a thing? Yeah, yes, it's work. That's why the whole books are written about this, right? It's not, we're not going to like solve everything sitting at a kitchen table. Like yeah, a lot of the stuff requires work to work out. Like what do these things mean? You know, what is a geometry? What does trigonometry mean? Like what's it referring to? What does a legal system mean? What is it like referring to, and so on. So uh, yeah, you have to actually do that, and because there are a lot of different ontological entities around, and so the question is, does logic apply to all of them? And so you can go around and find out, do they? And I think, like I said, with commands, you find out that it's the fulfillment conditions are the fulfillment of the command, and so that's the thing that a contradiction is unrealizable, which is the fulfillment of the command. It's unrealizable structure. So whereas just merely having a contradictory set of statements, it does not violate the law of non-contradiction, because you can totally have a series of contradictory statements, you just can't realize them. And you can have a system of contradictory laws, you just can't fulfill them. And so, and that gets to the difference between contradictions in semantic space, and contradictions in ontology. You know, the Nantucket rule 1 million years ago. We're not dealing with semantic contradictions, they don't even exist. We're only talking about contradictions in reality. But even when you get to semantic contradictions, and then you get to commands, well, now you've got a fulfillment condition that can't be fulfilled. So that's how like the structuralist would deal with this kind of example. Again, I don't know if that answers everything that Priest is talking about. I've got to go check that. I'm vaguely familiar with it, but not enough to go further
Yeah,
into
fair
it.
enough. I'm not expecting you to like off the cuff like
Yeah.
respond to something that's not read before, obviously. You might enjoy reading Spandrels of Truth by J.C. Beale as well, because he advocates for a view which is that something I thought you were going to be more keen on earlier when I was trying to offer it to you, was something like where you go, the law of non-contradiction, at least the version of the law of non-contradiction that's true, is one that covers concrete things. So it just says for any proposition, if it's about concrete things, then it's not the case that that proposition and its negation. But you know, you allow, at least conceptually, for there to be true contradictions of the semantic variety that don't involve reference to concrete things. And I thought that that would be attractive to you because it allows you to maintain the consistency of physical reality. but it just means you don't have to really care that much about sort of semantic contradictions, merely semantic ones. So you can forget about all these sort of paradoxes of motion or anything like that. It's just things like the liar sentence, Russell's paradox, that kind of thing, where you might say that they're both true and false. Anyway. So yeah, there's a whole load of nuance to this. None of this is easy. Right. Are there any other questions? Let's have a look. Very sycophantic. I can't believe I even showed that on camera. Karen says, I don't even read it out, and it's get out. Wesley says, every time you sin, according to Jesus, a piece of your foundation, your soul, blah, blah, blah.
Yeah, okay. That's not serious.
Does that happen every time you do a live stream? There's some, like...
There's always somebody, it seems. I don't know why, but yeah.
Oh, well. All right, good. I think I'm about to say that we're done then in that case. So if you just stick around, I'll end the stream, but you need to stay on so that it uploads your version. But...
Yeah, that's what I figured. I'm used to that part of it. Yeah, no, this was a good discussion. Working out like what your issues really were, and getting a chance to explain what mine are, I think was helpful. Even if you and I are still like confused, hopefully someone else will. Anyway, I'll get a good blog about it. I think there's some useful avenues here to explore and build out what I'm talking about.
Good. I wanted you to have the last word, so you have done, as far as I'm concerned.
Yeah.
All right, good.